Okay, good afternoon, everyone. Welcome to AI All Summit, Future of Equitable and Inclusive AI. The event is co-hosted by SCB10X, Sahara AI, and Sambanova. My name is Tanwa Apontip. I am the Senior Technical Advisor of SCB10X. I will be your guide for today's event. The summit today is focusing on exploring the challenges and innovations in AI, especially on the topic of decentralization, equity, and inclusivity. Right? We will be exploring a lot of topics today. Stay tuned. But before we start the event, allow me to thank our special partners. We have AWS, Google, Cohere, Cohere for AI, University of British Columbia, the Vector Institute, Stanford University, Together AI, the Allen NLP team at the Allen Institute for Artificial Intelligence, and who speaks French here? All right, I'm about to do something that I have never done before, which is speak French. École Polytechnique Fédérale de Lausanne. How am I doing? Good? Okay, great. Pennsylvania State University, the Fundamental AI Research Team at Meta, the Korea Advanced Institute of Science and Technology. Can I get a round of applause for all of our partners? Okay, without further ado, let's get started with the first session. Please join me in welcoming Sean Yun, CEO of Sahara AI, and associate professor at University of Southern California, and our moderator, our very own Pitai Mukaya Panich, our CIO and CEO at SCB10X.
All right. Thank you so much, everybody, for joining us. Good afternoon. Today, very excited. I am Thai Panish. I'm the CIO and CEO of SCB10X. And for us, SCB10X, if you don't know yet, we are the disruptive technology investment arm of Siam Commercial Bank, the biggest and oldest bank in Thailand. And for SCB10X, we invest globally in the area that could have disruptive impact to the banking and financial services industry. So that is AI and blockchain. And today, I'm very excited to welcome Sean Ren, who is the CEO and co-founder of Sahara AI, also SCB10X portfolio company. And Sahara AI just announced the funding round, Series A, yesterday. And so it's a very timely to congratulate Sean. Sean, of course, is a professor at the University of Southern California, and he teaches computer science. So I actually also would like to know what classes that he teaches, and also the area of research lab. So maybe later Sean can tell us about that. But Sean also have achieved so many awards, such as Samsung AI Research of the Year last year, 2023, MIT Tech Review 35 under 35, and also Forbes 30 under 30. And so welcome, Sean. Yeah, could you please introduce yourself?
Yeah, thanks for having me, Thai. It's great to be here and seeing so many smart minds and talents joining us together. So I'm Sean Ren. I'm the CEO and co-founder of Sahara AI, and also an associate professor of computer science at University of Southern California. My background is kind of interesting mix of both academia and industry. Been working on AI for over 15 years, starting my career as a PhD student at University of Illinois, Urbana-Champaign. Had my first job experiences back then working on a computer vision-based recommender system for fashion outfit recommendation. And then over time, I start forming my interest into knowledge graph, information extraction, trying to really formalize the world knowledge and common sense knowledge, and trying to see where this knowledge can be used to power our users' daily activities. In the more recent time, when I started my career at USC, I'm trying to integrate these symbolic knowledge graphs with a language model. And in the middle of that, I spent 1 year as a postdoc at Stanford as well, working with the graph neural network experts and also language model experts to trying to find the way to bridge these two types of technologies together. At USC, my interest has been sort of evolving over time, but mostly follow my students' interests. In the earlier years, we're still seeing these models are performing more like a toy, right? They can be very specialized models on certain tasks, but they cannot be a generalist and be applied to many fronts. But really, related to how I started Sahara these days, in 2022, I've been talking a lot with my co-founder, Tyler, and the core thing of the conversation was like, I've been playing with GPT-2 and then GPT-3 for another 6 months. I start seeing the huge sort of transition of these models' competence and ability by the generations of the iteration, right? And GPT-3 is no longer just a toy model. It's kind of like a generalist model. And on many fronts, like for example, translations, summarizations, it outperforms average human. So I was really thinking about when this trend, when we are in an inflection point that this model become really capable of automating parts of our lives, affecting our job opportunities, and also changing the way we can monetize through our expertise. Another problem involved, which is how the users who can originally own their sort of own data, the user data, the expertise, the way they interact with the AI models, how these users, including you and me, will be protected over time, right? In the ways that we giving out our personal informations when building a better AI model for ourselves, right? So the whole process of personalizations also means that you are trading off your user privacy, your data security, your control of the data to the centralized providers, for example, OpenAI, Meta, and Google. And the new problem space I've been really excited about before I started formally Sahara AI is to how to create a sort of provenance structure, infrastructure that can really build up a copyright system to trace or bookkeep how the whole AI applications has been created from day one up to data collection, model iterations, wrapping into application, and then eventually the API is monetizing itself. How can we have a structure to really, in a trustless way, bookkeep all of this process and then use this structure to attribute back to the upstream participants and stakeholders? I can share a little bit more about that, but that was like a quick summary of how I got started with Sahara AI.
Got it. So, Sean, it seems that in modern AI, what it being accelerated by three factors. So it's either innovation in algorithm, or in compute, or in data. It seemed to me that Sahara AI focusing on innovation in data area. Am I right? And can you actually maybe explain more in detail?
Yeah, I heard a lot of the sort of people's ways of structuring the AI industry into data, model, and compute. But my recent sort of a thesis or summary of the situation right now is I'm seeing right now the AI industry actually are coming from two parts. One is the scientific, intellectual ideas and innovations which involve what's the model architecture, what's the learning algorithms of things, how is this whole recipe about an AI foundational model gonna be created. And then there's another big part of this which we not often talk about is what I call resource collection and allocation and management process. This involves like where does the data come from? How did you get users' trust into giving out the data to you? And how would you put together compute resources given such a competitive landscape? And how did you manage a team of talents, people who understand linguistics, who understand social science, who understand algorithms to come together, work together? This is actually way beyond the AI sort of a research innovation perspective, but more onto the operationalization and organizational management. And I think if we're looking back in the past 1 year and see the winning sort of competitors on the landscape, they are actually doing very good jobs on the second part, which is how you allocate resource and manage resource to really streamline the process of developing AI. If you look at some great examples like small teams like Mistral, they have a small group of talents. They double down on their ideas, which is not like super magical ideas. Everyone seems to be knowing that this is how model can be created, but they actually can execute that in a very fast way to push it out. I think that fact is meaning the team who can really do good resource management and allocation can have a very strong advantage in the current development of AI lifecycle. And the intellectual idea might be a little bit hard to bring huge breakthroughs into the model's performance. So that said, when I was thinking about what is the kind of interesting problem space for me to work on, I'm actually tending to focus more on the second part, which is like, how can we provide assistance and support to help resource allocation comes in a better way? And that's where I connect AI with technologies like blockchain, and which is changing the relationship of the users rather than just changing the productivity of the AI model. Right? That's kind of like a very high-level view of why I choose to work on this problem space.
Okay, because you are the native AI person, I'm curious what are the key technologies in AI that driving the development of a Sahara decentralized AI platform?
Yeah, we have a mix of, we have an array of different technologies, and I think at the very core are two things. One is the cryptographic encryption methods, right? For example, I think the biggest concern right now about user data is that if you upload your data to a remote cloud, say AWS or Google Cloud, you basically lose control of how this data gonna be used further. They can tell you that, hey, we follow the privacy policy, we're gonna not doing X, Y, Z, but you have no transparency of that. So in the ideal world, what we want to achieve is that any data you send it to the remote server for model fine-tuning or inferences should be encrypted text, right? And only you are able to decrypt the text based on your own sort of a policy. So now the very interesting research problem in this space is, for example, fully homomorphic encryption methods where you can actually train a model using only encrypted data. And you are able to recover everything the model output, even though those are encrypted text. So that's one big space. Another big space is how do you use the blockchain to create a sort of a provenance of the AI model's life cycle, and then using that to automatically attribute people's contributions for every single model predictions. In the AI sort of research community, we call this problem as data attribution, where every single prediction of the model, you are able to find out what are the upstream training data points are contributing to the prediction. And this is a very expensive process that we don't have a good enough algorithm to make it usable at all. So I think it's all these like a really interesting open problems we are focusing on right now.
Yeah, I think one of the products that you are focusing on is personalized AI agent, which is pretty much create digital twin of user, and that you use user data to train the model to enhance the quality of the model. That definitely require a lot of control of data privacy. So curious, yeah, what is the solution that Sahara AI is using in order to do that?
Yeah, exactly. Like we are working with one of the largest creator agency company in West Hollywood. They manage 200 celeb creators. And these creators, their most important access is actually their personal chat histories and the media access, right? The images, videos, and so on. So the first thing when we work with them is we need to guarantee we have a solution where their data never need to go out of their local device, for example, their laptops or cell phone, while they can still enjoy the state-of-the-art language model ability, right? So because of this requirement, we've been working on this solution called a private LoRa, a decentralized private LoRa, where the user local devices will be used to save the LoRa module, the low-rank adapter module, plus some of the model components like the language model head and lookup table. but the vast majority of the rest of the model stays on the remote node, we call a public node. And all of the model updating and inferences will be turned into a secure transmission of information between the user local node and the public node. And this process apparently is gonna have an overhead because you now separate the model forward and backward computations into two physically different parts, right? And the parts in the middle is going through internet speed. So there will be about 20 to 30 times slowing down. So we are working on how to optimize this kind of slowdown to make the whole things much more streamlined to be used.
Since your inception in the middle of last year, you have already on board 35 enterprise customers and also more than 200,000 labelers. I'm curious, like, how do you onboard so many customers and people in the ecosystem to come to work with you so fast within 1 year? And what are the secret sauce for this? Can you share?
Yeah. I think one of the winning recipes is just like they needed someone who really understands AI to talk with their technical people, right? For example, when working with the enterprise about building agent solutions for them, the first thing they mentioned about is like the privacy protection and data security issue. Without fully understanding the technical solutions or the feasibility of the technical solutions to achieve these kind of properties, I don't think they will build a trust working with us. But apparently, I think as the Sahara's offered solutions here, the thing we highlight is number one, for enterprise users, always like how can we protect the user privacy and data security. And on top of that, we also convince them by telling them how we incentivize the broader user groups with different expertise on topics that can provide data to power their application. And this user, like I said, they work for other crowdsourcing data platforms such like Amazon Mechanical Turk or Scale AI or other these like a centralized data collection platform. These people only takes like a fixed sort of a rate for doing the jobs. It's basically an hourly rate. And then this company take a percentage of cut on top of the cost, right? But we are doing this in very different economic models. We make a marketplace when the demand, which are these small, medium business and enterprise come in, and then they specify their data project needs. And then on the demand side, we have this like 200,000 network of the data providers. They come in, they establish their track record of doing certain type of data or certain topics of the data. Over time, we will be able to power a distribution system to match the demand side with the supply side, so we can quickly navigate the data needs to the subset of the data provider who are the best candidates for doing the work. And we, as a platform, we take a percentage of cut. Everything is very transparent. So it makes us a much more competitive pricing system, as well as we using the reward incentivization to attract these 200,000 data providers to stay on our platform to be consistently perform well.
It's quite impressive that the enterprise that work with you are the like of Microsoft, Amazon, AWS, MIT, and others. So that's a very good track record. I'm curious, like, because you have been working very hard, what are the products that already live right now? What are you working on right now? And how about the timeline that you will achieve even more in the next 2 years? What are the vision?
We launched our marketplace for the enterprise users since last October. It's been going through the enterprise go-to-market for about 6 months, and then in the last 3 months, we're starting doing very extensive user testing about open up the marketplace so to the general public to use. Anyone, including you and me, can go on and upload this your personal data and make cleaning and massaging to make it into available data sets and publish it on the marketplace and monetize it. Or you can provide your expertise as sort of a service to help other people solve their project as well. And these products, we went through very exhaustive cyber attack defense sort of experience and other type of spanning experiments to be ready. And we're launching this product very soon to roughly like end of this month or early next month, we'll be open up this to everyone to use. So that's the marketplace product. At the same time, we've been building the Sahara blockchain, which is a L1 blockchain that can be used to specify ownership of data sets and models, and then use that to trace all the important transactions happens in the development cycle of AI, starting from data collection, labeling, then to the model fine-tuning, model iteration, and then eventually serve for an application that monetized through API or licensing. And that whole process is bookkept, so then you can use that to sort of attribute every single dollar being made by the application all the way to different stakeholders on the upstream. And you can also imagine this empower a new way of building an AI project, right? Right now, building a new AI project, prototyping it is really expensive because you need to fundraise, you need to get cash up front to pay for GPU, compute, and data. But really, we're providing a way for you to trustlessly involve different stakeholders, so you don't need to collect so much cash up front, and you can be focused on your part of the contribution. Either it's data, it's compute, or it's the model recipe.
Yeah, and then we have time coming up, so want to congratulate on the fundraising. So Sean just finished his Series A fundraising, raised $37 million US, led by notable investor Pantera Capital and also Polychain, and followed by other investors like Samsung Next, Nomad Capital, and of course SCB10X. Yeah, so what is your plan for the next 1 year? Any plan to expand more in other countries?
Yeah, totally. We are a global company from day one, so we have employees over the globe. Related to that, the way of using our new round of the fundraise will be a couple of things. Number one is definitely to recruit global talents of different products, design, blockchain developments, marketing, BD, and many others. So please visit our website and submit resumes if you feel like excited about coming to working together to achieve the dream with us. And then we'll also be spending the fund to really grow our ecosystem, because eventually we are an infrastructure provider. We give you the right features and functions that you can use that to achieve revenue sharing models, sort of a provenance. But really, we need a lot of applications and project builders to come to use our infrastructure, our SDK, our API to power your own application that you can achieve your own sort of economic models. So we are going to use this fund to support and sponsor all these project builders that share the same dream to grow the Sahara ecosystem altogether.
All right, yeah, thank you so much, Sean. So we're going to have the 5 to 10 minutes Q&A with the audience, and I would like to ask the audience to participate, because if you ask the question, you will get the goodies from Sahara AI. So we have 5 to 10 minutes. Any first person who want to ask the questions? Okay.
Hi, it's lovely to be here, and thank you for all the information just now. Just now you were discussing about expanding into other than enterprise entities and potentially submitting CV. So what help are you looking for right now?
Yeah, I think we are needing help from a couple perspectives, right? First, we need helps of talents of different expertise to come to the platform together. Right now, we are very actively recruiting for AI experts who are the people have, for example, knowledge about privacy-preserving methods for AI or language model. And then we're looking for security people who have a deep understanding of optimizing and accelerating the encryption algorithm to make it really tangible to be deployed on our current system. And we're looking for blockchain builders who can help us integrate the blockchains with the AI infrastructure that I mentioned. And apparently, we look for a lot of other people outside of the R&D. For example, we're looking a lot of marketing talents, BD talents, help us to build an ecosystem together. And this is the great sort of opportunity for talents of these kinds to come to talk to us.
Right. So in summary, AI researcher, blockchain developer, and also business development BD.
And marketing. Yes.
And marketing. So if there's any interest today, Sean is here. Please come by.
Thank you, Sean.
Hi, thank you for such an interesting talk. And this may sound like a dumb question, but in terms of user, I'm not in this AI space. Where do you get the data from, and how does it affect me as internet user or unknowingly providing you with the data? Thanks.
That's great questions. I'm trying to convince everyone that every one of you is contributing data to this different AI player, right? How many of you here are using ChatGPT, if you can raise hand, or similar language model applications, right? So every one of you who raise hands, you are contributing data to this like centralized data provider. For example, you ask questions, and then the AI give you answer, and then you will express your sort of attitude about the answer, right? You can say, please clarify the questions. I don't think it satisfies my information needs, and so on. So that kind of conversational process naturally provides feedbacks to the model to help it improve. And this is a very personalized kind of a feedback process, because many of the times the question you ask, it's very culture specific, very language specific. So every single one of you, the feedback is valuable for example, ChatGPT to be iterated into another version like GPT-5. But you own nothing over the feedbacks or the data that digitalize the feedbacks in the process of you giving this back to OpenAI. Not to mention, if you need to use GPT Assistant, you need to upload, say, spreadsheets or PDFs. Some of these may contain trade secrets of your personal business. And in this process, you already are losing your proprietary information to this centralized provider. And these things, you have almost zero protection right now until the regulation and compliance is maturized. And I'm sure the government is doing the thing, but from our perspective, as the infrastructure builder, we are thinking about how can we provide a platform that really decentralize the process of the user's sharing of data and give you a sort of a copyright mechanism that you can use that to pinpoint, hey, I'm the owner of these data points, and the model that was created using my data is because of the bookkeeping, you are able to become the shareholder of that model or the downstream application, and then you can get a share of the monetization opportunities those models are making.
So how does it work, Sean, in the future? People have to come into Sahara AI blockchain, and then you will have a lot of apps like messaging app, like GitHub equivalent, Wikipedia equivalent, and people can come and contribute the data. Is that the way it works? And then they can actually get to monetize their data with your blockchain. Is that
exactly? So for one particular example, right, we're talking to a project where they use the sort of smart glasses that take the ecocentric view of people's sort of activities, right? So let's say the user turn on their glass and then go for work or whatever for fun of a whole day, 8 hours of video recording, basically upload every day to a centralized server. And this data basically is really valuable for any of these robotics companies and the sort of a visual multimodal language model to learn in sort of a culture-specific and sort of domain-specific way. And now, if you will have a builder come to build on Sahara platform, every single frame of the video have the ownership records and it's recorded on the Sahara blockchain is immutable, then all of the model built on top of these egocentric data streams will be also recognize the ownerships. And that's a better way to really protect the user's sort of a control over the data and not missing any of the monetization opportunities down the road.
Yeah, get a quick question here. So with all the applications that we are familiar with, like let's say WeChat, Line, or Facebook, or just ChatGPT, with Sahara, what would be the new user journey having Sahara be a part of the game in order to protect our own privacy?
That's a great question. The user journey mostly stay the same as the current sort of AI development cycles, which is what we're trying to get to, because we don't want to create huge user frictions that they have to adapt to a very different type of user journey, right? Let me describe this from a very high level view, right? Let's say if you are a AI developers that you have your own recipe of creating a model. Now you come into the Sahara platform, you might first go into the marketplace to try to find some useful data sets in addition to what you already own to help you bootstrap a model, right? Once you own that data set, you will come to our no-code, say, creation platforms. If you are not such a tech-savvy users, then you will use the no-code platform. It looks like a kind of a playground of OpenAI. For example, to channel your data and then create a model of your in your customized way, and then you can deploy the model as an API and then publish it on the marketplace, so people will be able to browse and explore your models on the marketplace, right? And now this is where the monetization could potentially happen, because people start paying for API access of your model because of its domain-specific case. Now, the additional interesting thing outside of this user journey is, number one, you can potentially web package your data sets on the marketplace and then try to monetize your data sets as well as sort of a licensing mechanism, pricing model. And also you can say, I'm going to combine my data sets with other people on an ecosystem, or combine my model with other people on the ecosystem to create a bigger model. This is what we call model merging. There's techniques related to that, or multitask learning, you can do that as well. And in this process, you are basically start merging the ownerships to create a larger sort of a more complex shareholder sort of a mechanisms. And these are all supported on the market, on the current sort of a Sahara platform.
Thanks for the great talk. I really enjoyed hearing your perspectives. I wondered about the latency with the remote public nodes. How are you dealing with the latency between the model, the internet, and then the actual devices that are interacting with it?
Great question. So because of the decentralized LoRa setup, we have a model splitting. You have to go through internet speed sort of communications in between the public and user nodes. So through our empirical experiments, that slowing down is about 20 to 30 times, which is acceptable in the current stage, because if you're thinking about with the reasonably good GPUs like A100s or H100s, our inference speed with Llama 7 billion models or Mistral models is already over 200 tokens per second easily. So 20 times, 30 times slowdown give you like 10 tokens per second decoding speed, which is very acceptable. And apparently there's room to improve. The directions include like you can packaging the messages in a way that you can lower the frequency of the message transmissions between the two. You might get a little bit more gain out of that. So that's the promising directions. And really, what we're trying to research on the longer run is how to really accelerate other encryption methods rather than using just differential privacy, right? For example, multi-party computation, can we make it really efficient? There's actually some good papers at ACL conference showing that there's a way you can optimize the system, sort of a memory and sort of a matrix computation to really speed this up by 10 times. So we are seeing a lot of promising research results keep coming up on this direction. So I'm very hopeful that in like about 1 to 2 years, we'll get very useful technologies that have theoretical guarantees come from the cryptographic communities. I think things including MPCs and fully homomorphic encryption methods.
Thank you.
All right, yeah. Thank you so much, everybody.
Thank
Please
you.
come to talk to Sean afterward. He will be around.
Okay, hi, good afternoon, everyone. My name is Caitlin Zhao, and I'm a PhD student at Stanford, and I'm really excited to be here. Thank you all for inviting us. We have three really wonderful panelists who work on a variety of very cool generative AI work and just kind of broadly global perspective work in general. So yeah, I will introduce them very briefly. This is Vered, Amit, and Vinod, and we will just kind of kick off with some maybe like light introductions on kind of what you've been recently thinking about and maybe from the perspective of generative AI. Can we get started?
So hi everyone, I'm Vered Schwartz. I'm an assistant professor of computer science at the University of British Columbia in Canada, and I'm also affiliated with the Vector Institute of AI. I've been working on natural language processing for the last decade or so. More recently, of course, like everyone, working on LLMs, and specifically focusing on a few things, but relevant to this event on making LLMs more culturally inclusive.
Hi, everyone. My name is Ahmed. I am a researcher at Cohere for AI in particular, actually. I am, in general, working LLM space, but one of my main interests is multilingual LLMs, how to make LLMs more multilingual, more accessible, which includes actually, just like what Vera said, because when you go into multilingual space, then it's like making them culturally aware, or because all of the LLM, like a safety or alignment, all of them needs to be rethink in the multilingual context. I'm focusing on this in general.
Thanks, Ahmed. Hi, everyone. I'm Vinod Kumar Prabhakaran. I go by Vinod. I'm a staff research scientist at Google Research. I co-lead a team named, an interdisciplinary team called Technology, AI, Society, and Culture, where we bring expertise from different fields like computer scientists, social sciences, HCI, and many other fields. And we look at a variety of issues at the intersection of fairness, transparency, accountability, and community engagement. How do we bring community values and norms and community perspectives into the way we build AI? And my own personal research, I have been focusing on cross-cultural considerations into how we build AI, how we think about responsible AI, how we build guardrails around them. And basically so that what we are building can benefit the global society and not just small or few hubs across the world.
Great, yeah, that sounds great. Thank you for the introduction and just kind of a brief overview of what you've been thinking about. I'm going to open with a pretty broad question. We're curious to hear kind of from you all what you think the greatest opportunities for generative AI are. And from my perspective, and you've already hinted at this a little bit, but who do you think benefits the most from this sort of technology, and who might we be leaving behind, or who do we need to consider more as we're designing these technologies?
So I can start with a focus on large language models, because I work on language. I think the vision of having a chat interface where you can ask questions to get information, to get search results, and to perform a lot of tasks. It's something that people have been thinking about for many years, and it seemed almost unattainable. And so language models definitely do that in a very good way, of course with some problems that I'm sure we'll discuss a bit later. So the short answer is everyone can benefit from that, from the easier access to knowledge and from automating tasks. Also, if you think about more specific fields, in science and healthcare, maybe this could help with knowledge discovery, and in education, it could be used for having a personalized tutor. There are problems. This is not a perfectly working product, so there are things to improve that it would actually serve everyone equally.
Yeah, I think, there are two things about this, how we benefit from LLMs at the moment and how it can benefit from LLMs in the long term. I think this is an important question here, because in my view, LLMs has really huge potential, how we use phones today. It's hard to say we use phone for this or for that, but it's kind of part of our life and probably increase our efficiency in general. And I see LLMs is really kind of will be like a more efficiency boost, whatever we do in any area. But now, when we look at who really, the first question, like, do we really use this potential? I don't really think so. We use LLMs for very, very simple tasks. That's not really a part of our life in general. And very limited group, like societies currently using LLMs. I think this kind of problem, probably we will discuss more. Yeah, I can say that in general, this very brief, yeah.
Yeah, I'm gonna echo the points that are made already. I think in terms of capabilities, like we have come a long way in the last like 3, 4, 5 years. When I started working in NLP almost 15 years ago, it was a very academic endeavor, right? Like you write these like programs that you know that it's just like going to like stay in your lab, or maybe a few other researchers might download your code and like run it on their data or whatever. From that kind of way of doing research, things have changed a lot in the last like few years. But with this increased capabilities, like, it is rolled out, easy access for a lot of users. People are using it in various ways. But with this comes the question of responsibility as well, sort of how it's not just about putting guardrails around it for it to not generate certain things or not necessarily. There are many other ways of understanding how this technology is being used, and then basically thinking about social implications in the context of those use cases is important. So I'm actually in recent months, we have been kind of thinking about understanding that question of how people are using this, and what are the other opportunities of use, and thinking about responsibility from that perspective. And in doing that, one thing that I have also recognized is that when we are building these things, we think, oh, this might be used in a certain context, and we are building with a certain use cases in mind. But when you're rolled it out into the world, there are very creative ways people are using this for. Recently, I was looking through some LLM logs that are publicly available, and the ways that people have used it is not something that I have imagined, or I don't think people who are building it have imagined, and that kind of would be a good place to actually understand the opportunities and risks in that context.
Yeah, that sounds great. Thanks for your answers. And just to kind of continue on this question a little bit, you've all kind of worked on adapting large language models or generative AI systems to a broader culture. Amit, your paper recently won a paper award for kind of multilingual instruction following across lots of different languages. I just want to hear kind of more about what are the challenges and what are kind of the exciting kind of new opportunities that you've had when adapting to other cultures.
Maybe I can start easier. So not because maybe not the most important challenge, but since I'm a little bit more expert in the area, one of the challenge at least is really the accessibility, or do we have enough resources to broadly make this LLMs accessible? Language is one of that dimension for this. Truly, although we have this paper, we collected lots of data, for example, even start from the data point of view, there is not really equal amount of data for different languages, right? So this from the beginning creates a huge kind of negative diversity in terms of language models. If you are speaking English, or if you are speaking, I don't know, maybe Spanish, let's say, you can really use LLMs with more, for more tasks. But if you are from Turkey, or maybe if you are from Kazakhstan, let's say, it's very hard to use LLMs. There are, for example, we have this IA 101. It works in Kazakh, but it is very limitedly works on Kazakh. So you cannot really use in your life. So I think this is, at least in my point of view, one of the biggest challenge. Mm-hmm. It's not only about the data, but data is the one of the thing. Of course, how you do the multilingual optimization is another thing, but it is extremely challenging.
Sure, yeah, I completely agree about the data. In my work, I've been mostly working on English, but we did try to at least help, because of the problem of the lower quality of language models in lower resource languages. We tried to improve the cultural awareness of the English language model, or the a multilingual model when you interact with it in English, and you still need the data to know how cultures differ along various dimensions. So that's definitely one of the main issues. Even when you pass that hurdle, you could learn about cultural norms in different cultures, but then it's still hard to know when some norm applies, when do you want to take that into consideration. And then the last thing is, what do we do with it? Even if the language model is aware that it's interacting with someone from, let's say, interacting in English with someone from a non-English speaking country, from a different culture, how should it respond differently? Do we want the model to actually respond differently to users from diverse cultures? How do we avoid perpetuating stereotypes? How do we avoid creating this kind of echo chamber where people are getting the answer that they want to get instead of actually making us see different perspectives? So yeah, I have more questions than answers for that. It's something that we're still trying to figure out.
Yeah, I mean, 100% to both points are made by Vera and Ahmed. I think one way I think about the question of the points that Vera was making is I think we need to think beyond multilingual models to multicultural models, because it's not just a matter of the language models can generate sensible, logical looking pieces of text, but actually that being situated in the cultural context and can respect and engage with the cultural context of that language speakers is important. So thinking beyond multilingual to multicultural models. But then another thing is about when we are rolling out these models, thinking about the larger cultural ecosystem within which they will be deployed in. And that is, if you're rolling out you build a model or a language technology based on this model and roll it out in the US context, the kind of AI ecosystem within which it would be rolled out would be very different from, let's say, if it is done in India or Indonesia or Middle East, where the norms are different. There's the legal ecosystem around AI regulation will be different. The media and the journalism, journalistic sort of tech journalism kind of aspects where people are questioning issues with AI and society. Those kind of questions are in various different stages of maturity in different parts of the world. So AI education is different, at different levels in different parts of the world. All of that should be taken into account when we are actually rolling out these models. And that's something that I think NLP community typically do not think about. It's somebody else's problem, but I think it is increasingly becoming our problem.
Yeah, absolutely. I can't agree with that more. I feel in my own research, I've been thinking a lot about how older Americans, for example, interact with technology, and their set of needs is just completely different. And it's in the same culture, but we're just at a different generation. So we are all at ACL, which is a language technologies conference, first and foremost. But I'm curious kind of how you think about the ethical challenges of generative AI across other domains. So vision, and images, and video generation, and music. It feels like the risks across these mediums are not all the same. And so I'd love to hear your thoughts on how to wrangle with all of that.
Yeah, I can start. I think that there are some common ethical issues across these different modalities. So, for example, copyright issues are shared across all of these. Yeah, every one of these modalities has their own problems. So, for example, for text, so maybe every one of these types of models threatens a different industry. So, for example, language models threatens journalism and authors and many others. And image generation model threatens photographers and artists. And then you have video generation models that affects the movie industry. And so there's different problems there. And one of the, I think, more concerning things to me is actually not about language models, it's about image generation models and video generation models, because we live in a world where there's fake news, but so far images and videos were a way to actually verify that something is true, that something happened. And as these models are getting better and it's getting harder and harder to distinguish an AI-generated versus a real photo or video, it's really concerning because we're kind of like losing a way to verify reality. And similarly for audio models, they can be used for like scams. You can get like a phone call supposedly from a family member that sounds exactly like them asking you for money or something like that, but it's just a fake like AI-generated voice. So these are very concerning to me.
Yeah, I mean, I agree with everything Vera said. One thing that I'd just like add is that like, again, going back to the point about usage context, like I think it's sure each modality kind of poses like unique threats, and like some of the threats are like elevated for some of the modalities, like text and image, like because we afford more trust to some of these modalities than others. Like if we see like something in a text, like it may be questionable, but like you might still have like a kind of a little bit of a suspicion if like it looks fake. Whereas like in image and video, it's like much more, if it's like very believable, it's like people put more trust in it if it like looks believable. But then I think another thing is about, I think the usage context, like where multiple modalities like might be jointly used in like certain contexts. Like now it's the age of like multimodal models. So all these modalities could be mixed in. So it's in specific usage context, like it would pose like, or it would raise compounding new challenges when it comes to like the ethical consideration. So I think we should look into how these models are being used, or like where it's being used for, or what context it will be used for when thinking about like the ethical challenges.
I can just add, completely agree about the usage. And one like slightly additional dimension is actually also capabilities of these models are also not same at the moment. Like there are much more work in LLMs, so we are facing much more ethical or in general challenges about LLMs. But for example, like speech models probably will be in the same level with LLMs in a couple of years. Then we will see much more different challenges, maybe more difficult challenges for the speech models as well. So I think this is also another kind of dimension to consider.
Cool, yeah, thank you for your responses. I especially really liked your comment, Vered, about losing our ability to learn how to verify something. I'm curious kind of to hear a little bit more from you all from the perspective of like education on AI technologies, thinking about, like how much is the general population vulnerable because our understanding or conceptualization of generated artifacts is still quite nascent, and how like kind of what problems may continue to remain even if we had a very educated public about the dangers and artifacts of generative AI.
I can start. I think that even us as AI researchers, that we know that these models can be used to fake things. I think even we are susceptible to believing them, especially just like Ahmed said, that like some of the models in some modalities are better than others. So yeah, language models write text, produce text that is of high quality, higher quality probably than the average writing of, like the writing of an average person. Image models, sometimes, yeah, they generate something a bit weird, like somebody has 6 fingers or something like that, and then you can tell that it's AI generated. But it's not always the case, and they're always going to get better and better. So I think the only thing I can think of is just critical thinking. Maybe like as a rule of thumb, if something seems like too good to be true, then maybe it's not true. I think it's a really hard skill to acquire and to teach. So I'm not sure, yeah, how to do that. But I think that's the only thing that we have right now against it.
So, very brief. I think like even if the people get educated how to use these generative models, I think there are three like players in this space, right? Who use it, who it generates it, like who trains it, models, and also there should be regulators. Yeah. So even if everyone knows how to use perfectly in ethical context, I think without regulations, I'm not sure how can we have like a kind of a bar. So just to add this.
Yeah, that's great. So like thinking about like the distributors of this information and not necessarily just the creators and the seers.
Yeah, I think just to add to what Vera was saying about education and like how to help users understand like the problems when you're actually seeing some of these like misinformation or like fake stuff. But there's also like so education is like one place of intervention, but there's also a responsibility for us researchers in this field and developers in this field to actually put guardrails, like not guardrails in terms of like not generating hate speech kind of thing, but watermarking. We don't have, I mean, there's like some work in the last like year or two, very serious efforts in like watermarking like generated content, but that, there's like a lot more can be done there. Standardization of like that kind of, I mean, industry partners and researchers coming together to make standards around that so that like that can be reliable. So there's like other means of like intervening beyond just like educating the public. So that's one thing. And then another thing about like, you're talking about like ethical considerations beyond just like, this one context of like users using it. In addition to like the creators and the distributors thing, I think the process in which like we build these like systems like do have a lot of like ethically questionable sort of avenues, like data collection, exploitative data collection, annotation practices, labor questions around like annotation practices. So there's so many questions in the pipeline of like AI development that is not just about model training and evaluation, but like the data gathering, like the agency that communities have in sharing or shaping like how the technology could be built for them. There's so many of these kind of like questions that do not get much attention within the community of researchers in NLP particularly, but there's a lot of work in HCI and other AI ethics and STS, science and technology studies, and other fields have studied these kind of more complex questions at the intersection of technology and society, and have studied it for decades. So AI is not the first thing that has been rolled into the world. So there's a lot that we can learn from there and like bring into like the way we build technology.
Yeah, I love that. And I love your example of like, thinking about watermarking and what we can do as researchers. I guess like you could approach it like a security problem where it's like you're not trying to perfectly protect something, but adding friction or adding resistance is equally as valuable. So the next question I have is thinking about kind of what the ethical challenges how they vary across industry and academia. All of you being researchers, having been spent various amounts of time in academia and in industry, I'm curious what you all think, kind of how the responsibilities might be divvied up and how the challenges may compare and contrast.
You want to start as someone that worked in both?
Sure. I mean, I work in industry, so I can speak to that. But I mean, there's definitely differences in the kind of problems that you deal with in academia versus industry. I've looked at these problems when I was in academia, like as a postdoc, like, and there's like a little bit of like a distance from like the actual, bread making, or I don't know what's the analogy there, like the actual kind of like avenues of like actual work happening from like academic work. Whereas like in industry, you're like a lot more closer to like many of these decisions, and you actually see the messiness associated with it and how imperfect this decision-making process is. And that's the place where we are actually intervening with these kind of research, like, be it around like, AI ethics or responsibility in general, building data sets or intervention, model retraining kind of efforts. So I think in the industry setting, what I have come to recognize and like value is that there is a lot of importance in translating like the kind of insights that we gain from our research into actionable, easy and explainable ways of decision making for the policymakers or decision makers to actually implement. So maybe it's about like building frameworks to think about, or like having like a 10-step like process to actually think about ethical challenges about this, or some sort of prioritization. These are things that we in the technical research community tend to sort of undervalue, but those things, go a long way in actual practice, and that has to be not. That has to be coming from like research, right? Like, so all the research that we do in this community do shape those sort of frameworks and like those sort of like processes. But that translational work is super important in the industrial context, and it might have to be done within the kind of like how it's done in like different companies and different organizations and different industries have like different standards and different ways of approaching this, and so it would have to be done in those contexts. That kind of work, that kind of like research may not make much sense to be done in the abstract in academia, for instance. That's like one example.
Yeah, very, very brief. I think, I mean, not much to completely agree. Let me start from that. Of course, there is a huge responsibility from the industry because much more closer to usage, because like what is created is directly being used. But we also need to, like at least I'm thinking, there's a huge pace, and all the players in industry try to catch up the pace. So this is actually quite a limited factor. Yeah. That's why in this question, very brief, I would like to maybe highlight, actually academia has a really nice advantage because it's a bit free from this like catching up thing, and it's actually kind of gives the like this freedom to more like a fundamental research, especially in the context of ethics, and maybe teach industry what should be done in this context. I think this is a really, really nice opportunity because now we know in academia maybe you cannot train, I don't know, hundreds, millions of parameters, but you can do fundamental research in this context, which is extremely important.
Yeah, so I nodded when you said that we have an advantage because I thought you were going to say something else. I don't think we're completely free from catching up or everything. We're very like, overwhelmed with everything that's happening in industry and like questioning our like role in this. You probably identify with it. But I would say we do have an advantage of. I agree with the part that we can do more fundamental research, and I think that for us, there's it's not the best phrasing, but there's less of an excuse to work on something that is like ethically questionable because we don't have the financial incentive, we don't have a product that we're producing, so we're a little bit more disconnected from that. We could still, end up working on something that could be misused, so we should still be careful about that, and I think mostly do. I think that there's awareness. I don't know that everyone in academia like thinks about these things, but there's definitely awareness at the like institutional level, and like universities have like ethics approval processes. So it does happen. Yeah, and then maybe the other thing that we don't have in academia is sometimes, or we have that less than industry, is access to user private data, which is another thing that is a very valuable resource that industry, like big companies like Google have, but it's also something that's very like easy to misuse. So sometimes the lack of resources is an advantage.
Definitely, you kind of want to like have access to real world users, but not have the financial incentives and all the constraints that go along with that. Okay, we just have a few minutes left just to wrap up. I'm just going to close with a question for you all, which is, we've been talking about a whole host of ethical challenges here. I'm just curious if there's, like you have a few minutes to kind of uplift a particular challenge that you think is maybe deserves a little more attention or deserves more time. Kind of what would it be? What keeps you up at night that you wish more people were thinking about?
I mean, I'm going to just restate what I said earlier about like global considerations, because largely a lot of these like technologies currently are produced in like smaller or developed in smaller hubs around the world, like 3 or 4 hubs, like where all the AI development, most of it is happening. But that's like rolled out into the world in a multicultural world with like different values and different challenges and different societal realities and different histories, and I can go on. So I think thinking about like this like challenges at the in a global level, and about the cultural incongruencies that happen when you are rolling out this like monocultural development ecosystem to like a multicultural use ecosystem is like the most challenging for me to work with in industry and to see that happening. And it's like there's so many challenges there. So I'll stop there.
Yeah, I will also kind of restate what I said. So not to say everything the same. I think I will take the accessibility part. So okay, yeah, we should definitely make the language models, or in general, generative AI more multicultural, aware of all the culture. But even starting, we should make them more accessible. Because when we have more accessible generative AI, then we will have the opportunities to touch upon other dimensions of it. I think this is super challenging. It's not as straightforward as it says. So I think that's the main challenge.
Yeah, I agree with that. Maybe to add to that, I think that right now the power is kind of concentrated at the hands of a few big companies, and I think that it's. I mean, a lot of people have access to these models, but we don't necessarily, have control over how to make them more responsible or use them responsibly. And I think, having better access to the development of these models and maybe I don't know, support by the industry for academic partners to work on these things in a slower pace, not product-oriented way, responsible way. I think that would be valuable.
Awesome. Thank you so much for your time and sharing your insights, and that's the conclusion of our panel. Thank you.
Thank you.
Thanks.
Ron?
Thank you for coming to my talk. I'm going to talk about Together AI and our current inference strategies. I'm not sure if you know about us. We're the leading enterprise AI acceleration platform that enables developers and business to build and run their generative AI applications. So we have different tiers of services. A lot of the startups in Silicon Valley, a lot of the large enterprise today from Fortune 500 companies run their services either on our cloud, our serverless endpoints, dedicated instances, or using our software stack in their own cloud. Here's our team. So the philosophy of the team is that we want to bring our research innovations to actually to production so that we have the fastest and most reliable and secure inference platform. Here are some of our leadership team on the system research side. So our CEO and founders and other key members. So our customers really trust us in terms of technology that we provided from the research domain and pushes to the production. So we have a range of customers from smaller AI startups to larger international companies and enterprises. And a lot of our research is actually in collaboration with other fantastic institutions. For instance, we commonly do partnership with different institutes like Snorkel, Hugging Face, Meta, NVIDIA, and etc. If you are working in the AI domain, you probably know a lot of the key technologies that come from Together AI. So first, you might be familiar with Red Pajama work, different versions of Red Pajama. It's widely adopted in industry. From companies like Amazon, Microsoft, and etc. And we have the Stripe Hyena work, linear attention work. We have the speculator decoding work, Mamba architecture. I think most popular research from us that you probably know is the flash attention work. So we have different versions of flash attention from Together AI and our partners. Right now, we're in Flash Attention 3 stage, right? So just released. And then also, we have the mixture of agents as part of the recent work. Why people choose us? I think what we're really different here is we have the full stack solution. I don't want to call it inference engine. I think it's an end-to-end solution from the point of making a data recipe to pre-training, to fine-tuning strategies, and all the way to inference a model to be served. And then we're on the way of enable the functionality of bring your own model. So there will be a lot of flexibility in near term on our platform. I hope you and your institution can check us out. In terms of cost optimizations, we have the fastest kernels. We're really focusing on making sure that we have the best inference engine, the most stable one that produce not only latency but also throughput advantage, security, reliability, etc. as an AI cloud provider. So this is a figure shows our end-to-end platform from development of your own model to customization through fine-tuning and our own instruction tuning data set, and also immediate deployment based on different customers' interest. Together platform is a cloud AI platform. So a lot of the components are designed on top of the typical cloud AI interfaces. And I think the services that we provide is customers often serve their models on our cloud. For premium customers and mid-size enterprise, we often do VPC in their own cloud or serve their models on customized the third-party container GPUs. I want to give you some numbers. These are based on the 3.0 Llama releases, or these are older numbers. I think we're the fastest inference engine in the market right now. We serve more than 100 open source models. We really believe in the concept of open source. We think open source is the future. Now, compared to Amazon services that we did this continuous monitoring, our throughput is very, very competitive. Also, because we did our inference engine from scratch, so we have our own technology roadmap that's very independent of, let's say, NVIDIA technologies or other Hugging Face technologies. So overall, our inference engine providing very competitive edge over the other backend frameworks. So because this is a talk about technologies, I want to quickly go through our Together inference research. So really, at Together, we're focusing on building a multi-dimensional company. So we're not just inference is a key part, but we also have a pretty world-class data modeling team, as well as pre-training and fine-tuning capability. And pre-training and fine-tuning capability is being packaged and provided to our customers through our own cloud. So today, I'm going to focus about the inference and system and engines. So I think some of you, already building your own companies or you work in this field, you already know that building a state-of-the-art inference core engine is pretty hard. So you have to consider how you design the system from ground up. You need to consider how your compiler works, how your runtime strategies and serving strategies work. Also, you have to think about how your quantization, kernel design, communication optimization is. Plus, once you're done with your system, I think a lot of the attention is going to be moved to how you build your model level optimization, how you introduce further algorithmic innovations. So it's a very complex system problem to build the inference engine. So we have different versions of Pulsar since about 8 months ago we started building this. Now we're very proud that we're beating the state-of-the-art backend by significant margin, and we're trying to do even more of that through our combination of technologies. So building our inference engine Pulsar is a process. So we not only have to figure out how to build the general framework through, independent of NVIDIA technologies, we also have to make sure we have fast kernels and very easy to and compatible, easy to replace. So a lot of you knows that We have really fast kernels. That's one of our signature work. Most of our kernels on Attention and GEMS are faster than the state-of-art NVIDIA products. We also have right now I think we're getting closer to build a complete system platform which is scalable and very easy to support different types of new model architectures. We also started to do more and more work on the algorithmic level and modeling level. I think on the algorithm level, we're really focusing on building our own speculative decoding strategies that are different than the state-of-art. On the model innovation part, we started exploring novel model architectures beyond the transformers. Some of our research work, you probably have seen some of them, like strap hyena, mamba, and linear attention. One of the the interesting things that Together AI is known for is our modeling and algorithmic design. So we created this thrust called Turbo. We're trying to really sort of thinking about the economics of model serving. So we want to actually maintain the performance but significantly reduce the cost of serving. We created a Turbo Boost for our customers. It has a range of technologies that support our mission. Some of them you probably have heard of or have seen research along the line of this list of things. Most importantly, our cutting-edge work of not doing transformer models, but doing more of a novel architecture. For instance, like a Mamba 2, we want to have really super long context window. And we want to have a lot of features that today's transformers don't support. I think it's a very great thing for the research community, and we're trying to push these alternative architectures to production. And Turbo technologies is being embedded to our API. So for our customers, we have a customized set of different technologies that support their sort of metrics or what they want to achieve. Another work I think is quite exciting and is released recently. It's called Together a mixture of agents. So instead of having one large language model to produce a response, we have a range of different large language models with different parameter size, different architecture to produce a unified response that's more impressive than just a single large language model. So this work has been evaluated independently on Alpaca Evo leaderboard. We're actually beating a lot of the existing models in different categories of tasks by a large margin. I think our strategy here from research is trying to leverage mixture of agents and create such multi-agent collaboration inference framework for our customers. So soon you will see the actual product comes out from us that you can use, and you can utilize this along with things like iterative reasoning and model routing in your own service. I talked about inference being a game of having both fantastic system design, but also a key part of keeping inference cheaper, more economic, and high efficiency is really on the algorithmic side and modeling side of the innovations. One of the things that Together does really well than other competitors is we have our own way of doing our speculative decoding. So here is just a simple example on Llama 3B. After really amount of research putting into this domain, we're able to have speculator along with our system that outperforms the competitors by a significant margin. And this speculator decoding design, we can customize for different users and enterprises needed. We figure out a way that can do continuous learning without really degradation in terms of quality of the speculator, trained from the user's customers' data. Some of the benchmarks, I want to show you some of the benchmarks about the recent release of the Llama family 3.1 models. So that family contains 3 models, 8B, 70B, and 405B. They're all dense models. The main product that we're trying to push now is something called Together Turbo. Now, Together Turbo is not serving a reference model. It's a quantized version of that model, but we're trying to do a quantized version that's as close as to the original model's quality. So in the recent 405B release, from a third-party evaluation, you can see that not only that we can get to great throughput range, low latency in terms of TTFT, but also our qualities are great. So the first figure here shows in terms of the TTFT and throughput advantage over the competitors. Oh, sorry, it keeps going back. And we want to emphasize that you can, with Turbo, you can really achieve the best from both worlds. And this is on Alpaca Evo 2.0. We did evaluation with our Turbo model, which is a quantized version of reference model, compared to the other providers in terms of 405B and 70B, and you can see the actual quality difference. So we really want to emphasize that together, accuracy is really a core of our model service. Oh, sorry. And then also the numbers on things like Helm, Classic, and Arena Hard also shows that our models have an extremely high quality. So that's something that we really care about and guarantee to the user and our customers that this is being preserved very aggressively. And if you're curious about our serverless endpoint, you can go to our serverless endpoint and just do some testing and look at what you're, in terms of a TPS or other types of criteria they're looking for, you're looking for. I have a little demo here just showing that. I asked a question about, in terms of, sorry, the prompt is telling me about San Francisco. That's where our company is. And I actually gave you this kind of output and hitting certain kind of TPS. You can do this exercise yourself, and you can change the model there to different types of models, and you can test it yourself. Okay, I think my time is up. Thank you. If there's a Q&A session, I'd like to take questions. Thank you.
Okay, so Ben Atiwaratkun, as you can tell from the name, is Thai. So for those of you who are Thai and looking to get into the industry, this could also act as your inspiration. Right? So let's start with a self-introduction. How did you get from Thailand to Together AI, and then how has your journey been?
Yeah, thank you so much for inviting me for the talk, and it's been kind of surreal coming back to my home country to talk about AI. And my journey started, I guess, like in high school. I guess my way getting to the US is I did physics Olympiad, and then I got admitted to school in the US, and kind of the rest is history. And then I majored in math, and then I did a PhD in statistics, focusing on deep learning. I started working at AWS, training large language model for code generations. And then last year, I got to know the team at Together, and decided to join because it's such a great company and such a good opportunity.
All right, and as you have heard, Together AI has pushed out a really fantastic product in the AI space. And as a senior machine learning researcher of Together AI, Ben will today give us a glimpse on how that has been done. Right? So we heard about mixture of agents, right? And how it's like immediately better than using single model inference. Can you tell us a little bit on the concept of like what is mixture of agents? How does it work? And we have heard mixture of experts before. What are the differences between MOA, mixture of agent, and what we have heard, MOE, mixture of expert?
So I'll take the second question first on the difference between mixture of agents and mixture of experts. So for mixture of experts, the different experts in abstraction collaborate with each other in feature representation space. Whereas for mixture of agents, different agents collaborate in natural language. So we can think of it as a way to do collaboration in a very interpretable way, where in the middle of the mixture of agents layer, we can probe and understand how different agents collaborate with each other and refine the outputs. And the overall motivation of mixture of agents, so this is our first iteration to show that multiple models can collaborate and refine their own outputs, similar to how humans collaborate in real life. So we demonstrate that in conversational tasks, when we have a set of models being proposers. Proposers essentially take a prompt and output by proposing different ideas. And then we also have aggregators that act as a manager, if you will, looking at all the outputs that the proposers generated, and then synthesize another output that pushes the quality of the overall response to be much higher. And we really believe that the multi-model inference will be the future, because so I guess the way language models started at first is we try to hello? Yeah, so the way language models started out is we try to compress all the knowledge of the world into a single monolithic model. And that is a good way to start initially, but eventually people will try to do more with less. So the industry is gradually evolving to use smaller models. Some models is specializing in certain areas. Some models might even have like private information or knowledge on custom domains. And it's also a lot more natural for multiple models to be that are experts in different domains to be working together, rather than having a single model knowing everything, which is something that is quite hard to do.
The way I try to understand this when it first came out is that as a VC, right, SB10X is a venture capital. So when we invest, we actually have a lot of people looking into the same deal. Some people are technically inclined, right? We look at the technical side of the deals, such as myself. Some people are more financially inclined, right? But in a deal, the more important the deals, the more people we put on it, because we want the expertise of everyone to propose their thoughts on the deal. So those are the proposers. Like each of our members are the proposers in this model. And then the aggregator would be the management team or the CIO or the CEO that will look over all the proposals and aggregate all the thoughts together and make one single decision whether we want to invest in the deal or not. So that is my effort in writing myself out of job, because now my CEO might replace me with an AI, which hopefully will not happen. Is that about right?
So, yeah, so I think that's a very good intuition about how the overall framework works. Yeah.
Okay, fantastic. So if that's how it works, let's talk about the implication of using mixture of agents. So I have two main questions here. You are using multiple model or multiple agents to do inference, but how do you actually do it? Like, how do you architect them to talk to another? Do they take turn talking? Do they have interaction? How does it work?
Yeah, so essentially analogous to how humans collaborate and cooperate, we architecture mixture of agents to occur in multiple layers or multiple rounds. We can think of multiple rounds of discussion. So the proposers propose a lot of things, and then the aggregators look at all the proposed outputs and generate outputs for the next round. And then this process happens a few times until we see kind of diminishing return in terms of increase in quality. So then usually we do a few rounds of discussion. We can get to something of very high quality already. We also look at kind of the Pareto frontier of the cost or latency versus the quality gain. But mixture of agents is really a really good way to really squeeze out the quality in the cases where the decisions or the quality of the output matters a lot more than and is worth investing the latency or the token budget into.
So just like in real life, more meetings is not equal to higher quality, right? Only the first few meetings are fruitful discussions and the rest of them are just hashing the same point. So totally understand that part. Let's talk about the implications of having mixture of agents. From the paper, the most fascinating part to me, if you haven't seen the paper, I really encourage you to go look at the paper. So one of the results that came out of this, and feel free to correct me if I misunderstood it, one of the major results to come out of this is that mixture of agents can combine open source models, all open source, right? Which mean you can use it in commercial settings without having to ask anyone permission because it's open source. Mixture of agent can combine open source models and the result will have better performance than state-of-the-art centralized closed source model. Yeah. So, name your closed source model, like ChatGPT or whatever. If you use mixture of agent with just open source models, you actually get better performance. Now let's talk about the implication of that in AI application. Like, as an application builder, what does this unlock for enterprises?
Yeah, that's one of the best observation in terms of the features of mixture of agents. So what it allows is really enabling the feedback loop in terms of synthetic data generation. For example, so currently if we want to generate synthetic data before mixture of agent, people would go to OpenAI or Anthropic's API. But there's a limitation because there's certain legal clause where you can't really use the generated output to train other models. But for a mixture of agents, we can operate on open source models or fine-tuned versions of open source model. So this really unlocks a lot of possibilities because once we get to the point where the final output is of such higher quality, is of such high quality, higher than the closed source model. In that case, we can feed that generated output to smaller or more medium-sized models and get kind of the benefit loop without being constrained in terms of the legal implications. And this will create a lot of feedback loop. And we will have a blog post coming out soon on how we can push the performance of very small open source model to be much better with the synthetic data generated from mixture of agents.
Okay, so as of now, what we have heard is that mixture of agents allow better performance with open source models, allow you more freedom in your AI application. But let's talk about the trade-off, right? Let's talk about the operation trade-off first. Can you give us, because since you are inferencing multiple times, what does that say about the latency of the application, and what does that say about the cost of using this kind of solution?
Right, yeah. On the latency is naturally higher. So when we look at time to first token for mixture of agents, essentially we, in the original paper, we have to wait until all the proposers and all the aggregators finish generating. All the proposers finish generating until the proposer can generate the first token. So there's some waiting time there, but there would be a paper coming out soon on how we can unlock this, like reducing the time to first token of the mixture of agent framework to make it more real time. So this can be used for something for like real time conversation that enhance the quality on top of open source model as well. And in terms of costs, so again, we go back to the Pareto frontier. So we look at the cost of OpenAI models, Anthropic's models versus mixture of agents on top of the open source models. And mixture of agents actually stay on the Pareto optimal frontier in a sense that given capability, the cost of doing mixture of agents is the best. There's, as in there's no other model even closed source model that can outperform mixture of agent at such cost or at such latency. Yeah.
Okay, so right now it's slower and more costly, but more improvements are coming down the line to make it on par with single model inference. Yeah? Okay. Let's talk about philosophical trade-off then. If you're using single model, you kind of know the odds and ends of that model, right? Some models will tend not to say a certain thing. If you use multiple model in mixture of agents, are the hallucination tendencies compounded because you're using more models, or are they more checking and balancing one another and basically negate that kind of biases in the system?
Yeah, so based on the benchmark scores, they seem to be, so the diversity of the proposed output seems to help in the sense that they tend to make the final output more balanced. And this kind of, this is related to how, I guess, how proposers and how aggregators are trained as well. And the mixture of agents framework can actually steer some of the directions of developing, for example, a more fair or more balanced aggregator, for example.
And I think that makes a lot of sense. If you think back to your workplace when you have a meeting, right? Some people will have tendency to be biased toward one end, and the other one will be biased toward the other end. And what makes the end result better is actually the discussion between the two ends to find a common ground that is understood by both, right? So I think that makes a lot of sense. Let's talk about the actual usage of this technique then, mixture of agent. Using 5 models, so if I'm not using Together AI, right, what I have to do is, let's say I want to use 5 models, I have to go find 5 providers that can run 5 models for me, which might not be the same provider, right? Some of them will be on AWS, some of them will be on Google, some of them will be on my own machine. So after I provision the hardware, then I need to make all the machines talk to one another, which if you haven't done DevOps, is a nightmare, okay? So once they talk to one another, then you need to have an aggregator that look over the result and try to aggregate the result into one single result and make sure that it is optimized. That seems really difficult. Now, can you walk through the experience of using this with Together AI? Like, which part of this process is automated? Which part of this process you still have to make a decision before you can use it?
Yeah, so actually the process of building mixture of agents with Together API is extremely smooth because at the base layer for single model inference, we already optimized a lot on that already. So, and yeah, to your point, it is, like if you look at the overall process, it is quite challenging. And hosting one model at scale, serving thousands or millions of users is very challenging. And hosting thousands or tens of thousands of models is even more challenging. But and this is why everyone who wants to use and build on top of OpenAI should come to Together AI, because we really have a strong team and specialize on model inference for single model, and also with our API, you can build on top of mixture of agents very smoothly with the abstraction layer of the Together API.
Okay, so I want to step away from mixture of agent a little bit. Like Leon talked a lot about all the other improvements that Together AI is having as well. And one of the research and improvement that Together AI has been at the forefront of is flash attention. Right? If you haven't seen flash attention paper, we are now at flash attention number 3. Right? Flash attention number 1, I fully understood how it works. Flash attention number 2, I kind of understand how it works. I only know that it makes stuff a lot faster. Flash attention number 3, I have no idea how it works. I just know that it's significantly faster. So Ben was talking about how all of these new innovations will be coming into the pipeline to make mixture of agent better. So let's talk about, for example, flash attention number 3. Like, how does this integrate and synchronize with mixture of agent to make it more on par with single model inference? And how does it work? I just want to know.
Yeah. So yeah, flash attention is optimizing on the core piece of transformers, which is the attention operation, where the attention operation, if not done appropriately, then the memory I/O can be high, and that leads to higher latency. So flash attention is really at the heart of Together because it's optimizing at the base layer of single model inference or even single layer inference extremely well. And from that, we build on top with higher and higher abstraction. But overall, yeah, the core idea of flash attention is, there's a lot of knowledge of kind of how to stride the GPU kernels to be extremely aligned with how the hardware performs. So from flash attention one, where the concept is kind of more high level and less specialized, to the NVIDIA GPUs, where flash attention 3 is extremely optimized, where even if you do things like torch compile on or CUDA graph, you would not get to that level. And this is why we have Tridao, our chief scientist, and also the whole kernel team to optimize on the base layer. Yeah.
Okay. That's just one thing that when I study Together AI, one thing that I really love about Together AI is that optimization doesn't really happen at just one layer, right? You have optimization at the hardware usage, at the model layer, at the application layer, at the user experience layer. And to me, that keeps Together AI competitive in this space that is highly, highly competitive. But I would like to hear your answer. Like going forward, what do you think would make Together AI remain competitive in this AI space?
Yeah, so in terms of system and kernel optimization, we're very close to the physical limit of pushing things in terms of memory I/O, in terms of flop, close to the speed of light already. So in terms of the memory movement and all the computation, we're quite close. Once we're approaching speed of light, the other parts that will unlock new capabilities in terms of new efficiencies would be on the modeling perspective. So things like for, let's say, long context, things like Mamba, which does parallel scan. So instead of quadratic complexity of attention, we can alternate other layers in the network to be Mamba layers. So with linear complexity, things can be a lot faster for extremely long context. And extremely long context is really it's going to be a new paradigm shift in a way, because once we can encode a lot of context, that can replace a lot of, for example, fine-tuning tasks that can add more custom knowledge and makes the model become a lot more flexible, if you will. And on top of that, algorithms that push the inference efficiency further is something like prompt caching, where if we have like multiple successive calls where there's a lot of repetitive or redundancy in the prompt, we can cache that, and we can spend only an incremental amount of compute to iterate the applications, for example, chat or some advanced reasoning strategies like tree of thought, chain of thoughts, for example.
All right. Unfortunately, we run out of time. It's been a great chat with you, Ben. Everyone, can you give Ben a round of applause?
Thank you.
Having said that, let's start our second half of the event with a panel on the future of open source AI, trends and predictions. Thank you.
Good afternoon. Welcome to our session today on the future of open source AI. My name is Nisha Sibwongli from Amazon Web Services, and I'll be your moderator today. Open source AI has transformed the landscape by making advanced tools accessible to researchers, developers, and organizations globally. And it helps to foster collaboration and rapid innovation. You have multiple open source projects that have empowered individuals and organizations to contribute to AI advancements regardless of resources. So as we look ahead, open source AI will play a pivotal role in shaping localized developments, such as language models, for specific regions and addressing key ethical challenges like fairness and transparency. So today, our panelists will explore these trends and share the predictions for the future of open source AI. With me here, we have our panelist, Kun Kasima Tanpipichai, the head of AI strategy at ACB10X and Typhoon AI. We have Kun Akshita Bhakia, the senior researcher engineer of Allen NLP. And we have Antoine Bosselu, assistant professor of EPFL. Can I have the panelists do an introduction on who you guys are and what you do? We can start with Kun Kasima.
Hi, my name is Kasima Tharnpapichai. Thank you for having me. And right now, I'm leading a team called Typhoon. And Typhoon is actually a series of open source large language models that are optimized for Thai. We don't just do models, we also release open source data sets and tooling and research.
Hi everyone, I'm Akshita Bhagia, and I'm a senior research engineer on the Allen NLP team at the Allen Institute for AI. I've been involved in multiple natural language processing libraries, which are open source. And most recently, I've been working on building open language models.
Hi. Oh, that feels loud from here. I'm Antoine Bosselu. I'm an assistant professor at EPFL, specifically focusing on NLP and LLM technologies. We do quite a bit of open source development. One such example was a model called Metatron that was specifically adapted for the medical domain that we released early last year, and that there's been a lot of work that's been built on top of. When I have a bit of free time, I'm also involved in kind of the Swiss national initiative for open source development of Gen AI technologies called the Swiss AI Initiative, where we try to develop open source models for a wide variety of societal applications that are of a particular import for the Swiss context. So happy to be here and discuss these topics in more detail.
So we'll start with looking at the broad trends before we go into a more focused discussions about the trends and predictions around open source AI. Antoine, as we looked into the future of open source AI, what major trends do you see shaping the field in the next 5 to 10 years?
Yeah, so I think the way that I like to answer this question is not by looking at the next 5 to 10 years, but looking at the previous 5 to 10 years and even beyond that and seeing what the trends were there in open source. Generally, open source has been one of the biggest drivers of development in almost all digital advancements. I guess as a question, how many folks here use an iPhone as opposed to an Android phone? Statistically, more of you use an Android phone, which is built on top of open source platforms. When you use cloud services, you're probably using some type of Kubernetes or container-based infrastructure, which once again was developed by the open source community rather than being something that was led by very large companies from the start. And I think at the end of the day, the reason for that is that lots of different organizations, lots of different individuals, lots of different institutions have very different use cases that they need to be able to design and use these systems for. And sometimes an all-in-one solution, like what we see right now in Gen AI, just doesn't really work. And open source is kind of how we break out of those patterns, how we give people the ability to personalize, to customize the types of tools that they need. And in the end, that tends to be what takes off in the long run. So while right now we may be seeing this consolidation, this homogeneity in the types of models and platforms that are available, I expect that to expand rather quickly once the true power of the technology kind of takes off.
Akshita, what do you think is like the most critical trends that you foresee? The most critical trends that you foresee?
So we have seen a lot of development in modeling work. And one of the things that we know that these large language models rely on is data. And a lot of it is web crawl data. A lot of it is US-centric data. And we now are seeing these trends where a lot of open data is kind of getting closed up now. And so one of the things that I hope and expect to see is more open source, more crowdsourced data curation efforts. So that is using the data that we already have available, which is open source, in a better way. We know that higher quality, smaller amounts of data is usually much better than large, maybe lower quality data. So I expect that there will be more data curation efforts with the data that we have. The other thing that I hope to see is better data collection efforts. So these would just not be only for English, but also for other languages. And so I expect and hope to see that we build more partnerships on better data collection in general. And then from that, what I hope to see is more work in building monolingual models for languages other than English.
So from the modeling side, I think the most heartening trend that we're seeing is this idea of composable models or agentic workflows, where we're not just relying on monolithic models to solve all the problems, which I think opens the door for a lot of open source models, model developers to play in. And I really hope that trend continues into the future. I think all of us on the panel probably agree that it would be unfortunate if just a handful of private organizations controlled this technology. And I think that, like what Antoine said, looking backwards, that seems unlikely given the amount of importance of this particular technology. It's like, why did things end up this way with the internet? And it comes down to trust and ownership. And I think that if AI turns out to be as important and transformative a technology as we think it might be, that those two things will also be important for AI. So I think that's really heartening and promising for open source development.
We have seen that in technology, open source has been a key driver to a lot of the innovations. And the panelists have also mentioned that, whether in terms of Android or other prior technologies, because of the key importance, it is likely to be similar for AI as well. Let's move on to the evolution of open source AI, especially in emerging markets, and like the impact on the local innovation ecosystem. Kun Kasima, how do you see open source AI advancing in regions like Southeast Asia, right? And what roles do you see initiatives like Typhoon will play in shaping AI development in these areas?
Yeah, so going back to the idea that if you take on the premise that open source or AI is going to be really critical, I mean, looking at the history of how these commercial models have developed, there's constantly been a gap between English performance and the performance in other languages. And our mission at Typhoon is to fill that gap and try to keep things caught up. The reason we go open source is that I think it develops better software. I think this is proven throughout history, and I think this is also, thankfully, the culture of working in the AI space as well, of researchers sharing open source work. I think it makes the quality and the performance of the models better. I think open competition is actually good. I think having multiple teams working on the same thing, the ability to build on top of each other's work, I think is really helpful. And I think the larger goal isn't necessarily we're trying to win. The adversary, I was just at a conference earlier that's the language summit for regional languages, ASEAN languages, and I was talking to the head of AI Singapore, and we were talking about how the adversary isn't us. It isn't other Thai companies. It isn't even other places in the region. The adversaries are the handful of companies on the west coast of the United States, right? So I think collaborating on that level pushes the whole space forward and pushes the whole region forward. And I think that's the kind of ball we have to keep an eye on, rather than sort of like trying to compete and zero-sum game it for ourselves.
Why would you say it's important to do a regional, basically, I would say region-specific AI models? What's the importance of that? And how important do you see is the importance of localized data sets? Why do you see this is important?
A lot of levels. I think I could talk about this for quite a while. I'll try to keep it brief. But with the example that we used at the very beginning of starting our project was using GPT 3.5, and GPT 3.5 spoke some Thai. It didn't speak it very well, but really the highlight for me at least that was really obvious, if you ask GPT 3.5 how to make grilled chicken, but you ask it in Thai, it'll bring back a recipe that starts with set your oven to 425 degrees Fahrenheit, right? Which is not, Thai people don't have ovens. we don't use Fahrenheit, right? So, but it will respond in Thai in a little bit of broken Thai. From what I know, working out at tech companies out in San Francisco, it's not that they don't care about this issue. It's just that it's not a priority for them to look at this. And so if we want better alignment, if we want these models to work well for our cultural context, I think the best people to do this are Thai people, right? I think we understand and we care the most. And I think one of the things that I like to highlight is that, you know, some of the arguments I hear sometimes is that Thailand imports all kinds of technology and software from other places to use, but I think the real difference between what we're doing now, what we've done then and what we're trying to do now with AI is that previous generations of software, like let's say, you know, a word processor, right? It's a frame that you fill with the data that you want to fill. But with this particular technology, language models, it's fundamentally cultural, right? So language is cultural, and then we want to fill that with the cultural data that we control, right? That we sort of have agency in deciding what goes into training these models, rather than, you know, companies that are just sort of mass crawling internet data and happen to catch some Thai tokens and, you know, see how that goes. The next level of that is, you know, alignment and steerability, right? And so some of that alignment work, I see it as product work or UX work, right? When you look at that alignment work, it works really well in English, but not necessarily as well in Thai. And people are looking for you know, knowledge transfer, cross-lingual knowledge transfer, and cross-lingual behavior transfer. But ultimately, like, these models think in English, right? They reason in an English style. And so do Thais reason differently? Do Thais communicate differently? I would argue yes, right? The next thing is probably sovereignty, right? It goes back to making sure that we are in control of what goes into these models and how these models perform, and have an understanding of why they perform that way, especially if we start using it for critical tasks like governance. You know, if we wanted to consult these models for governance, we probably want to know what went in them, right? We probably want to understand the kinds of data, the kinds of alignment processes, and this is not necessarily transparent from these overseas models. And finally, in terms of localized data, I mean, the data is really the beginning of all of it, right? When I started working in the space, I was like, oh, it'd be fun to learn about AI technologies. But the technologies are sort of like, their architectures are kind of in place, right? The real work to do is data work, right? And it's about collecting data, cleaning data, finding data, understanding the data landscape. And that really is the bulk of the work that makes the thing perform correctly for, you know, aligned to your local context.
So how do you, like, you know, how do you actually get access to those data, right? Especially with a lot of people talking about like data becoming like more proprietary, right?
We were just talking about this as well. I think this is our work, right? This is the challenge that we have right now. I think the data landscape in Thai is significantly different than the data landscape in English. And so I think the approaches that have worked well in English data collection are not going to work well in Thai. And so it's a matter of going out there and probably figuring out what works in our context specifically, probably approaching IP rights holders to get access to their data for whatever reason that they might be interested in. I think it's about doing education, outreach, and probably a bit of like negotiation to figure out what we can develop as a beneficial win-win solution in getting that data for training.
Talking about regional specific models, I understand that Europe has multiple regional specific models and actually initiatives on this. Antoine, would you like to comment on this?
Yeah, so you know, one of the great things about Europe, you know, much like Southeast Asia, is that it's a very diverse place with lots of countries, different cultures, local dialects associated with each of these countries, and there's quite a few supercomputer centers there as well. So you end up with quite a few local initiatives. You know, we obviously have one in Switzerland. But there's also a major one associated with Spain, some with the Nordic countries in Scandinavia, some in Italy, and essentially a big push to actually be able to develop language models that, you know, much like the Typhoon Initiative, are specifically linked towards being performant in the languages that are covered in these different nations, with a further push to actually having kind of continental language models as well. And I think the most important thing there is, much as I'm sure it's important here, is to try to find a way to work together. GPUs burn a lot of energy. And if we're kind of replicating these same ideas just in different places, maybe that's a good way of doing reproducible research, or at least, showcasing its benefits. But it's also nice when we can actually kind of work together to create common resources and be able to develop models that don't just work for one place, but that try to work for all places. And then hopefully one day transfer those ideas into an even broader global setting.
Thank you for sharing what you see in Europe. Let's move on to the future of open resource NLP tools and the role in advancing AI research. Akshita, given the rapid pace of development, like in LP, where do you see open source AI tools like, for example, LN and LP heading in the future? And what new capabilities or research directions might we expect?
So for those of you who don't know, LNLP was this Python library that we built for exploring different model architectures in NLP. Of course, we don't do that as much anymore. We're kind of consolidated towards transformers now. And so I think, for instance, Hugging Face has done a really good job of streamlining some of these efforts and to reduce the overhead of getting started. As to where we are headed, for instance, one of the things that we want to do at LNLP is to sort of address every single step in the pipeline of building an open language model. So that does not just mean the modeling code itself. That's like one very small part of it. The things that we are also making an effort towards is building open source tools to curate data sets, to process data sets, and do that at scale. We are building tools to look at what is actually in all these large-scale data sets and to document them a bit better. Of course, you have the training code, and then that also needs to be hardware agnostic. So there is effort in that direction, making it more scalable. And then, yes, you have efforts for, you have your base pre-training model, and then what do you do to make that more useful? So we have efforts towards building instruction tuning libraries and doing inference better. So these are some of the things that we are building towards. More broadly, I think the goal here is that a lot of language modeling development has so far happened behind closed doors, and that's not really that's not good for research. That's not good for building better models in general. And so one of the things that we focus on is ensuring that at every given step, your pipeline is open so that the stakeholders, and these are people who are building these models, these are people who are using these models, these are people who are affected by these models, they get to have this insight into what is actually going on when we build these models. And so the first step really is transparency, right? You want to have discussions about, how to make things more culturally appropriate for a particular language. And they are messy discussions, but ultimately, how do you even have those discussions if you don't know what's inside the models? And so transparency around building these models, I think, is a big focus.
What about a potential for more specialized NLP models?
So specialized, by that, I believe you mean language models for a particular purpose?
It could be, yeah.
Yeah, sure. So the way I think of it is that, yes, pre-trained models are, you can think of them as having general language capabilities. And then based on that, you go into more specialized things for particular use cases rather than trying to build one thing that tries to do everything, because then you're not serving every individual need properly. So there are these instruction tuning things that you can do. Yeah, so you can think about building specialized models in that effort. But again, the key thing that I keep coming back to is transparency and how you have these conversations around building special models for a particular cultural context or a particular domain. And so you at every point need to know what is going into your models and what data you have. And so the conversation around building specialized models has to start at transparency because that's kind of the key.
So if I could, I actually would love to add something to that as well, in addition to transparency, so that there's a clear view of what's gone into the model already. I'd say kind of a foil to that is whenever you want to do specialization of a model, evaluation and especially comprehensive evaluation is probably one of the most important things to get right. Ultimately, it's, I think, an area where the open source community could actually potentially work together to build at greater scale. Because the type of evaluation you need for this type of specialization of language models is actually something that isn't, I would say, native to open source community, which tends to be very decentralized. And in fact, you need kind of a very comprehensive effort to put together the type of benchmarking sets to make these systems effective. When we worked in medical language models, there's a few benchmarks that existed to actually be able to evaluate on, let's say, the US medical licensing exam or the Indian medical licensing exam. And you can find some things here and there. I won't go into details about why it's actually kind of silly to evaluate on both the US and the Indian medical licensing exams, but I'm sure that thinking about it a bit, it becomes obvious. But one of the things that we did is that we actually took this model that we had created and we put it in front of 15 doctors who interacted with it, who created an adversarial evaluation set of day-to-day questions that they would actually want to ask such a system, and then evaluated its responses on a 17-point scale. Every response evaluated something like 15 times by one of the doctors. And the goal there was really to actually put this model in the settings where it would actually be used. And that's actually a very difficult thing to do. It requires a ton of effort to get right. The next step beyond it is something that we call a randomized controlled trial. And evaluation can become very, very comprehensive when you want to do it right. But just kind of grabbing benchmarks where you don't necessarily know how they were collected or what the questions actually are, or what the answers look like, doesn't actually necessarily give you comprehensive systems. And I think this is one of the places where some of the top tech companies who are not necessarily as well aligned with the open source movement do quite well. They're willing to spend $15 million on evaluation data sets to make sure that these models are working in the settings that they're supposed to. The advantage they have is that they create platforms that allow them to collect interaction data with humans and see the exact settings where the models need to operate in as well. And that's a place where the open source community both has a disadvantage in that it's difficult to bring together these types of resources, but also an advantage just due to the sheer number of people that are working in the space. And with a tiny bit more kind of coordination, I think that it'd be quite possible to catch up to that level of rigor in evaluating these systems.
Just to maybe add a little bit to that. So I was talking to a couple of researchers at ACL, and they're building an Italian language model. And so this thing that you mentioned about evaluation, because there are fewer benchmarks in Italian, what they end up doing is translating English benchmarks into Italian. Yikes. And hoping that acts as a proxy. And
We've
it's
done that.
Yeah, it's unfortunate, right? So connecting back to this issue that we need to have more effort into building models for other languages, and that starts at data. We have this unfortunate thing that we have done as a field where you sort of work on English language NLP, and then you group everything else under multilingual data, and that's not really serving any particular language as well. And so the effort sort of is skewed in this direction of, oh, this is a technically interesting and challenging problem to solve of how do we deal with smaller data sets. And sure, you can do all these tricks, right? Like translating the evaluation benchmark or starting with a pre-trained language model in another language and hoping some of that work translates. But ultimately, what you need to keep in mind is the end goal, right? Which is serving a particular language community better. And so at some point, you have to acknowledge that the banded solutions are not going to work. And you have to be willing to do the messy, often unglamorous data work. So I do really feel that as a community, we can come up with better ways to incentivize that.
Yeah, just to build on that too, it's actually these kinds of evaluation data sets are a great touch point for academia and industry to work together. So part of the conversation that we've been having is exactly this. It's TIE evaluation data sets, and we did something similar to start. There are no evaluation. When we started our model training process, there weren't any evaluations that were in TIE, so obviously you translate. And if you look at commonly used, widely used evaluation data sets like MMLU, which is like, it's supposed to be a general knowledge evaluation data set. Except when you look at the details, the history evaluations are obviously American history, right? And so you take that, you translate it, and you're like, oh, it works in Thai, but it knows American history spoken in Thai, right? So, or it has Thai understanding, and so that's obviously insufficient. But we've been talking in the region through organizations like VizTech, which is a research institute here, AI Singapore, us, to collaborate on building these Thai evaluation sets that are open, that can be examined and contributed to from the community, and that builds a certain amount of credibility in the evaluation data sets. I think actually the Stanford HAI report talked about this as well, that's a way for you to build this credibility into the kind of work that you're doing. And I think open is kind of the only way to do it, because, I don't know, it's like if I don't know, some model builder, some private model builder was like, oh, our models are good at medical. You're like, okay, how? You would want to see what they evaluated on, right? You'd want to see the actual details of what's going on. In
Being open is about transparency, right? And talking about transparency, we're going to see the increasing importance of AI ethics and fairness in open source projects. Antoine, as AI models become more powerful, and we're starting to see it more and more, right? We talk about, potentially like AGI, right? And widely accessible. What ethical challenges do you foresee? And how do you see the open source community address these challenges proactively?
Well, I could spend the entire remainder of the session speaking about the ethical challenges of AI, but I think where I'd start is to think about where the open source community can actually, or the open community in general, can be one of the leaders in mitigating some of these ethical challenges that are naturally involved in AI development. One of the biggest ethical challenges that I generally see is just that AI is quite unfair across populations. I'm sure we all know that a lot of AI development is driven by major tech companies, typically in the US and in China, which generally means that AI is more performant in these countries, but also, interestingly enough, a lot cheaper. Many of you might be aware of issues at just the input of AI systems, starting from tokenization, where it can cost 4 times as much to essentially pass a sequence of words that correspond to one meaning in English, same meaning in, let's say, Thai, 4 times as much, just because the tokenization is not necessarily optimized for that system. That kind of creates an incredible imbalance of power when access to a service is 4 times as expensive, for one group of people as opposed to the other, and then also works worse for that group of people. So I'd say that one of the areas in which we can already start fixing these issues is to look at problems like tokenization. Looking at tokenization, paradoxically, is actually pretty cheap. Like, training a tokenizer is not super expensive. Granted, all the downstream experiments can start adding up to a fair amount. But starting from that point can already create greater opportunities for fairness within the AI community. I'd say another area is also in data provenance, which was spoken about before. right now, essentially a large part of the data that's taken to train these models just comes from crawling the web without a worry in the world as to who that data belongs to, who created it in the first place, and what they might think about the fact that an AI system is now being used to train on that data. There's some real ethical questions there, but I think as part of the open community, we can start trying to set standards. We can actually start looking at whether that needs to happen. Do we need to train on all public data to make good systems, or would a subset of data that has been, already, let's say, given a permissive license to be able to use, that, has given permission to be part of a common crawl, would we get performant models by, training just on that data? These are research questions that we can try to answer, and amazing folks at AI2 have already started to do as well. But we can take the next step on this as we already think about things like that in terms of evaluation and alignment. There's lots of questions that can be answered, and I guess to be a bit controversial, I think that there's a lot of answers to these questions that certain tech companies don't really want to find answers to. And so it's up to the open community to kind of take charge on that and actually lead the way forward.
Yeah, I absolutely agree. And I guess going back to the question on ethical development, I think even to have those conversations around what constitutes ethical behavior and what is fair and what is unfair and how that applies to various cultural contexts, open source development is actually going to enable that conversation to happen, right? So it's not that. You want to have those open conversations by ensuring that that people are aware, again, that like this is how your work is developing, and so they get an insight into it. So building open source tools that allow you to look at these things, allow you to look at your data, allow you to look at, oh, this is how this data was filtered, or these are the things that we consider to be toxic. And again, that's its whole separate conversation, right? What do you consider to be toxic, and that may also vary by culture. So having those tools in place is enabling you to start having those conversations. And so in that respect, also just open source development is already playing a huge role.
So we touch upon the theme of localization, ethics. All right. So how do you balance between like innovation and responsibility? Kun Kasima, would you like to comment on that?
Oh wow. Okay. A balance between innovation and responsibility. I mean, I think working in a decentralized way and working in an open way automatically balances some of those things, right? Being transparent. Working in the open, it's like sunlight purifies. It's that kind of thing. If people can see the kind of work we're doing, I think we are constrained by not doing anything terribly bad. I think the transparency, immediately addresses a lot of the issues that we're talking about in terms of the ethics, right? Democratizing in general as a community, democratizing the work that we're doing with this technology in general already mitigates some of this. You spread out the power instead of centralizing it into the hands of a few. I would say being measured by the community of people consuming your work in a way that is as revealing as possible. I think that immediately puts you in a place where you need to act in a responsible manner.
So I think if I could add something to that, a great point is, responsibility and innovation don't necessarily have to be two sides of a scale. I think responsibility is an opportunity for innovation in many ways, to think about ways they agree, to think about ways to potentially do things differently, and not necessarily go down the same paths. They really agree that we've gone through before. I guess I have a bit of a European mindset on this, where Europe is probably one of the places that has enacted some of the most comprehensive legislation around data provenance and around AI. And I will admit that places some real limitations Big fans of the EU AI Act out there. It places some real limitations on some of the research, some of the development that can be done, that large tech companies have to grapple with, that startups and academic groups have to grapple with. But it's also an opportunity to think about how one might develop AI within larger constraints around data protection, around the rights of the individual. And I acknowledge that in the short term, it probably creates growing pains, complicates the development of AI technologies, but in the long run, it could actually create better AI systems that are more respectful of some of these, let's say, goals that we might have for how AI should interact with humans in the first place. And so we'll see how it turns out ultimately, but I think that in the end, it'll create some incredible opportunities for innovation at the AI frontier to be thinking about how those principles should be brought into the AI development pipeline.
Today, we have touched upon the theme of what are the trends and the potential predictions for open source AI. We talk about growing localization of the models and also the data sets. We talk about the ethics around AI and how do you balance that between innovation and also development as well, and ethics. So I would like to ask if you have any last words, final thoughts from the panelists on this. Maybe we can start with Akshita.
Yeah, I guess one of the things that I think we can learn from other fields is that they for most of their professional memberships, they have this professional code of ethics, right? And that's true for medical science, that's true for lawyers. I guess as computer scientists, we kind of just show up to the terminal, right? And that's the end of that. I think one of the things that we can do is to have those conversations as we are learning about computer science. So that has to be part of our education in terms of how we build these models, or in general, how do we do computer science more responsibly. The challenge, of course, is that because of the way computer science and open source community is set up, a lot of people have maybe untraditional pathways into the community. So maybe as the open source community, we can come up with our own code of ethics, and that's something that we set for ourselves, and that's something that we try and adhere to.
Kasanima, any last word?
Yeah, I guess I'll close with the fact that I feel optimistic, right? Meeting people like Akshita and Antoine, who are part of this larger movement to continue to push into doing more open research tools, models, development, and doing it in a transparent way. Feels like there's a lot of us that are pushing on this, and I think that if we continue to band together as open source is open to doing, I'm pretty optimistic about the future of what's going to happen with this technology.
Antoine, would you like to have any last words?
Yeah, I mean, first I would completely agree with what was just said, and I think that the optics of having an academic, a senior research scientist at a nonprofit institution, and the head of an open source research team in industry up here kind of really makes it clear just how broad and diverse the open source community is and who actually participates, which is a real strength and asset because it brings in these diverse perspectives. I guess my last note would be that, you started off this panel by asking, where will open source be in 5 to 10 years? Truth is, I don't necessarily know, but I do know that it will have done something, just as it has in the previous 5 to 10 years and the previous 5 to 10 years before that. Ultimately, when a lot of people come together in a decentralized manner and try to push the best ideas forward, some great things come out, and that's been true in a lot of other fields of computer science, and it's also been true in AI since its inception.
Or maybe be the leader in, transparent and accountable AI development could be one of them.
I think that's Akshita's role over here, actually. So
I'm sure it's all of our roles.
So thank you very much for your time today, and hope this session was useful for you. Thank you very much for the panelists, and also SCB10X for hosting this event. So thank you very much.
And thanks to the audience for joining us as well.
Yeah, thank you.
For having us.
Hello, everyone. Thanks for having me here. My name's Amol. I'm part of Sambanova Systems, an AI hardware accelerator company. And I'm an engineer on the machine learning team. So today I'll be talking about redefining speed and efficiency in AI. In particular, we'll be talking about data flow as a new paradigm for efficient AI, and the memory wall problem and how Sambanova's RDUs try to scale this memory wall problem. We'll look at a proof point for LLMs, where we're able to achieve more than 1,000 tokens per second for Llama 3 8 billion inference without using quantization and using less than 1 server rack of hardware. We'll also look at an application where data flow really excels, composition of experts, which is running many small open source fine-tuned models that can outperform large monolithic models. So everything on this slide is from Golami et al. From their paper earlier this year titled AI and the Memory Wall. And the key observation, I think it's getting cut out, but it's that the time to compute an operation is the time to actually do the math, to compute the arithmetic, plus the time to provide the data to your compute unit. So the time to actually compute arithmetic is scaled up using hardware flops, whereas the time to provide the data to the compute unit is limited by memory. And the authors of the paper notice, and with previous work, they noticed that for the last 20 years, hardware flops have scaled much, much faster at a rate of 60,000 times over the 20 years. And in the same time, memory has only scaled up by 100x. What this means in practice is that your compute flops are often underutilized, and your compute units can't be fed with data fast enough, so all transformer applications are bottlenecked by memory on GPUs. One of the solutions that the authors of the paper describe is to rethink the AI accelerator, and that's where data flow and RDUs come in. So what is data flow? Data flow is creating an execution graph and tracking how data flows through the graph. If we compare this to the von Neumann architecture, such as on CPUs, they are much more generic and look at one operation at a time and how to do that in a generic way. But data flow looks at the entire pipeline end to end. So here's an example with a simple convolution network. This is an inference example only, but if you were to have training, you would also have some backward nodes as well. So you would define your convolution graph using PyTorch or TensorFlow. And then what these programming frameworks do behind the scenes is actually lower it to an execution graph. And this graph consists of which kernels get run, in what order, and what tensors go in and out of each kernel. So to actually run this on a GPU, we use kernel by kernel execution, which means for each operation, you load the kernel instructions, you load the tensors required for that operation from memory, then you fill up all of your GPU to do that operation. So for example, if you were doing matrix multiplication, your entire GPU would be doing mapmul at the exact same time. Then you would materialize your results to off-chip memory. So once you're done computing, you have to write it back to memory before loading the next kernel and starting again. Of course, this means there's a read and write at the start and end of every operation you do, which results in a lot of memory overhead. And as we discussed, memory is slow. So before we get to how data flow gets around this issue, I'd like to quickly introduce RDUs. So RDU stands for Reconfigurable Data Flow Unit. And our latest model is called the SN40L, launched in September 2023. It is based on the 5 nanometer TSMC process. And there's some more statistics if you would like to see. But the important part is that we have a 3-tier memory structure. So each RDU has 0.5 gigabyte of on-chip memory, which is SRAM. up to 64 gigs of HBM, high bandwidth, high speed memory, and then up to 1.5 terabytes of high capacity DDR memory. And again, this is per RDU. In a quarter rack server, which is about this tall, you can have 8 RDUs, which together can do a trillion parameter model. Okay, so zooming in on an RDU, each RDU consists of 4 tiles, and each tile is an interleaved grid of compute units, PCUs, and memory units, PMUs. And these are all connected by non-blocking switches. So if a grid of PCUs and PMUs is working on one operation, the adjacent PCUs and PMUs can still be working on a completely different operation. Each RDU also has direct access to the HBM or DDR memory, so it doesn't have to go through the host to figure out which memory to get. Now we can get to how data flow is different from kernel by kernel execution. So in data flow, using the same convolution network example, we can dedicate different parts of the RDU chip to specific kernel operations. So instead of dedicating the entire chip to do one convolution network, we would say that this part of the chip will do convolution 1, the next part will do pooling, the next part will do convolution 2, and so on. So multiple kernels are laid out spatially, and because the chip has memory and compute weaved together, it means that the result from convolution 1 can be passed to pooling, which can be passed to convolution 2 without ever going to your off-chip memory, without ever having to write to your HBM or DDR. This also gives you natural operator fusion. So whereas on, and that's because kernels that execute next to each other in time, so one after the other, are also located next to each other in space, which makes them a lot faster to run. Kernels can also be working in parallel. So as you can see on the example, that if pooling is working on sample 4, convolution 1 can have already started on sample 5. This is super, super useful for low batch size runs, which we'll see in the inference examples. But you can also, we can of course also do tensor parallel and split up the kernel for large batch sizes and large operations. So to quickly recap, kernel by kernel is the GPU way, where you're bottlenecked by memory bandwidth and your host overhead. You optimize one kernel and one kernel operation at a time, and performance comes from trying to parallelize that one operation. So squeezing as much performance as you can out of that matrix multiplication. In data flow, you eliminate that memory traffic to off-chip, and you optimize the whole pipeline using the data flow compiler. Performance comes from parallelizing the entire pipeline, and because we have fewer memory calls, you can use a much higher capacity memory. Okay, I promise that's all for the hardware. What does this higher capacity memory allow us to do? One application is true resolution computer vision. So if you're doing convolutions on a GPU, you may have to downsample your image or look at just parts of an image to be able to fit that image onto your GPU. This can result in information loss. Whereas on RDU, because we have that higher capacity memory and we're able to efficiently use that higher capacity memory, you can use a full resolution image and get more information. A data point for this is from Argonne National Labs. So this is an older paper from 2021 where they were training on Cosmic Tiger using the V100 GPU with 32 gigabytes of memory. And they used the exact same model, exact same data, but when they switched to RDU, they were able to load higher resolution images and saw an immediate bump in their SOTA accuracy. RDU or data flow also gives you speed. So just another data point before we move to LLMs, where vision transformers are able to be served 3 times faster than H100s and trained twice as fast as H100s. Great, so now that we've covered vision models, the next big question is, does data flow work for LLMs? And I think what we found is that the answer is yes, they definitely do, because we were able to get to more than 1,000 tokens per second using 16 chips, which is a half server rack system, and full precision. So no quantization and without using a lot of hardware. And the key observation that enables this is that the structure for transformer is pretty repetitive. So modern transformers like GPT and Llama are mostly just decoders with some modules at the start and some modules at the end. And this chain of, inside each decoder, in this chain of decoders, there are several other smaller operations. So on a GPU, once again, you may have 4 to 6 kernel calls per decoder. And because you're running through 32 decoders to generate 1 token, you have more than 100 kernel calls to generate 1 token. This is a lot of overhead, a lot of reads and writes to memory, and we don't have to do this on Dataflow. On Dataflow, you can map out the entire decoder as 1 kernel, and then since each decoder is a chain, there's decoder 0, decoder 1, decoder 2, and there's no difference between the decoders in terms of what operations they're doing. You can just reuse the kernel and not have to load a kernel for all 32 decoders. So there's 1 kernel call for all 32 decoders. This is just what we went through to get to this performance. So our out-of-the-box compiler gave us a baseline performance of 100 tokens per second for Llama 3 8 billion inference. And then we created that kernel for the decoder, mapped it onto the hardware, got rid of the kernel launches between each decoder, and then scaled in tensor parallel to 16 chips, which gets us to 1,100 tokens per second using 16 chips without quantization and without a lot of hardware. So we followed the same strategy for different model sizes, Llama 7 billion, 70 billion, 405 billion. And these are all using 16 chips with FP16 weights and using mixed precision for activations. And you can see the performance we get. These models are also live on our website, so please feel free to try them out at sambanova.ai or fast.snova.ai. Okay, this is the last section of the presentation, and this is covering an ML application of Dataflow and how we can see better LLM accuracy for a wide range of tasks when using Dataflow. So this technique is called composition of experts. And again, we start with an observation that there's a lot of information that we need to capture these days, including a wide range of domains, a wide range of tasks, a lot of different languages, and we also try to get monolithic models to do them all. So we try to mix data in certain ways, we try to augment data to get large models to capture all of this information. But this leads to larger and larger parameter sizes. So we've seen that larger and larger models perform better with more data, so we keep using larger and larger models. And this means that model sizes have exploded to encode more information, but large models are, of course, expensive to serve and even more expensive to train. And we know this is a huge problem because the community has responded with compression methods like distillation, quantization, or low resource training. So let's rethink a little bit. Do we really need one model that does everything? And there's some good news. So small, open source, fine-tuned models can beat large general models. Of course, not on all domains, but in their fine-tuning domain. So here are some examples I got from online leaderboards. So for example, on GSM 8K for math, Arithmo Mistral 7B beats PaLM, which is a 540 billion model. For the Berkeley function calling leaderboard, Salesforce's XLAM model, which is a 7 billion model, beats GPT-4 and Llama 370B. For OpenAI's human eval benchmark for code generation, CodeStroll, a 22 billion model, beats Code Llama, which is fine-tuned for code, and a 70B model, and also Llama 370B. So with that, we can introduce composition of experts. What if we could run several of these small, fine-tuned, domain-specific experts concurrently? What if we could route the query when it comes into the appropriate expert and make it all still look like it's one model? So I know what everyone's thinking, that this is just mixture of experts, but there's a key difference. So in mixture of experts, all of your experts are the same architecture, and they have to be trained together. They also have to be trained with the router. So this is full end-to-end training. It's very expensive. You're not able to swap out models during runtime. In composition of experts, your experts are trained completely differently. They don't even have to be the same model. So you can pick up any model from the open source community. And we train the router completely separately. And in COE, models can be switched in and out. And all it requires is inexpensive router training. This is the pipeline for COE. This is from our paper, so it has a little more information than I mean to introduce. But you can essentially, a query comes into the router. The router is a nearest neighbors algorithm to classify which expert should answer your query. Then your query goes through a prompt engineering module, which transforms the query and appends chat template tags so that you're routed to the appropriate expert. The correct chat format template for the expert that has been classified. And then your query goes to the expert, and the expert answers your query. Once again, I'd like to highlight that it's very, very easy to switch models out. So for example, if you found that CodeStroll performs better than GPT as your coding expert, you can just switch it out. You might have to fine-tune your router, but that takes about 40 minutes of training, so it's very, very inexpensive. And these are results for the first version of COE, which was using 16 experts that were all Llama 2 7 billion models. And you can see that the COE performs much like a much larger model. You will notice that our MMLU score in this case is pretty low. But in our internal testing, we found that fine-tuning the router to pick better experts for different tasks, and also increasing the number of experts gets a big accuracy boost. So by the time we got to V03, sorry, I was pressing the wrong button. So by the time we got to V03, our MMLU score jumped up 20 points. This is still with 16 experts, so we just fine-tuned our router, and we were able to improve MMLU. We also updated some of the experts. So again, a 20-point jump, and we didn't train any of the experts. We just fine-tuned the router. So the big question is, why hasn't anyone tried this before? And the short answer is that it's not possible on GPUs. So on a GPU, for each model you load, if you were to load it the same model or a different model, it doesn't matter. You have to keep switching out your kernels. And GPUs also don't have that high-capacity DDR memory, which means that for every model you load, you have to load the weights from disk and then write them back to disk, which is super, super slow. So as you can see in the graph, the blue part of the chart is model switching, and the orange part is model execution. And on an H100, model switching takes a lot more time than the actual model execution. But on Sambanova's RDUs, model switching is a fraction of the time of model execution. So yeah, we get up to a 30 times switching speed up when using RDUs. And how are we able to do this? So let's say you have 16 experts with 8 different architectures. Let's say one of them is Llama. Yep, that slide, please. So let's say you have 16 experts, and one of them is, and they have 8 different architectures. So you could have, I don't know, like Llama, GPT, BERT, Mistral, and other things. So you would load all of your architecture execution graphs onto the chip all at once, and then they are never unloaded. And then all of your checkpoint weights are loaded in DRAM, specifically in DDR. And then whenever you use a model, the weights are moved to HBM, and you can use it really, really quickly. So there are some limitations and improvements to this approach. So a limitation is you always have to use the router. You always have to fine-tune the router if your experts change significantly. But again, this is a cost we're willing to pay because it's very cheap to train a nearest neighbors algorithm compared to training a transformer from scratch. And then some improvements are you could do access management to models. So the router would be able, can programmatically check who is using the router and limit access to models. It can also chain model responses. So for example, if you want to explain a legal concept in another language, you could ask a legal model to generate a response, pass it through translation, and then pass it through video generation. And we can scale to more experts or create better embeddings. And that's all from me. Thank you so much. If you want to reach out, this is my email here. Thanks.
All right. Hi, everyone. I'm Tejas. I'm a PhD student at the University of Southern California. And I'll be the moderator for today's panel on personalized AI. And alongside me, I have our panelists for today, Professor Shomir Wilson, Dr. Scott Yee, and Professor Minjun Seo. So to start off, could each of you give like a brief introduction of yourselves and maybe tell us one recent thing that you're excited about in AI? Could be anything. Let's start with Shomir.
Sure. Hi. So thanks for the introduction. I'm Shomir Wilson. I'm an associate professor at Pennsylvania State University in the USA. My research is in natural language processing, and I also do a lot of work in privacy and computational social science. And the question you asked, I think it was what's exciting us about what's happening in AI? Okay. So general question, I'll give it a general answer, but it's true. There are lots of big questions that we're facing now about our relationship with technology that I think about sort of in parallel with my research, and the future of human interaction, the future of entertainment, how we consider ourselves to interact with other people, what we want out of technology and what we're getting out of technology. So there are philosophical implications, and those just by nature become interdisciplinary because we need to interact with social science researchers and folks who are law scholars and even philosophers to figure those out.
Hi, everyone. I'm Scott Wentao-Yi. I'm a research scientist at FAIR at Meta. FAIR is a fundamental AI research team. I've been in the field for quite some time, probably almost 20 years, and my field is mostly NLP and then a little bit machine learning and information retrieval. And my recent research focus is on like retrieval augmentation, generation models. The question is about what's the most exciting things in AI. So I think for me, the most exciting thing is probably the pace of the innovation these days. So a lot of people are talking about large language models. These kind of terms were never spoken by people outside of field, even just a few years ago. And because of that, a lot of like progress has been made, and a lot of things that even like seasonal researchers, they didn't think that could be solved in like 10 years or 20 years, and suddenly it seems to be mostly solved. So those kind of things are very exciting. And to be honest, even though we are kind of professional researchers, we still don't know how far and how fast things can change quickly. So I think being this moment itself is a really exciting thing.
Awesome.
Okay. Hello, everyone. My name is Minjun. I'm assistant professor at KAIST. I work on language modeling mostly, so it's really exciting to be here. So I think the most exciting part of recent trend in AI is, for me, is the fact that, well, when I was actually doing PhD, like 10 years ago, it wasn't really clear if we could call these neural nets some intelligent being or something close to intelligence. But then I think these days, of course, there are a lot of debates about whether we can call it really intelligence, but at least I think it's much closer to what we usually call intelligence. And yeah, I really wonder what the limit of this technology is, how far it can go. So I think we'd love to talk about that too in today's panel too. Yeah, thanks.
Awesome. Thanks for the introductions. So let's start off by, let's get onto the topic of like personalized AI. It's a pretty broad term. And there's a lot of different aspects of personalization that we could look at when it comes to AI systems, like privacy, like preference learning. So I'd just like to hear what aspects of personalization come to mind first for you guys, and what potential benefits you could see personalization offering to users. So yeah, you can go in any order, really.
Okay, sure. So as you said, yes, pretty broad question. I typically approach questions like this as a privacy researcher. So I think about issues of consent for data collection, because to personalize anything, you have to get some information from the user. And I think folks typically acknowledge that when they interact with technology, like they need to give some information up to get some benefit. But how that information is collected and how fully aware the person is, that can vary. So that brings into mind questions of how to provide consent to users in ways that are responsive to their needs, and that they can actually understand, that they can fit into their uses of technology. Because even as a privacy researcher, we've got to recognize privacy is sort of a secondary task. It becomes pervasive, and it's important for feeling comfortable with technology, but at the same time, the person wants to load the website. The person wants to use their phone. They want to try on the VR headset. So I see that as a big sort of upfront issue with personalization, how to make this so that the person doesn't feel creeped out by this new thing that they bought or this new app that they're trying.
So in my career, I'm mostly in industrial research labs in Microsoft, in Meta. So for me, I think there are two things that come to my mind. One is that if you are actually an engineer or scientist actually working on like supporting different products or trying to build different kind of recommendation systems, so usually the problems you think about is that how come we cannot actually make the product better in personalization? So when you do like applied machine learning, you actually need a lot of like signals or information about user to actually make the system better. So that's from the system building side. And then even though we know that, for example, the most talked about area is probably online advertising, but you probably can still see that even nowadays that the different kind of companies may know a lot of about your behavior or information, for example, do the shopping or whatever. And it still actually doesn't do perfectly well. For example, maybe you already purchased something, it doesn't know, and it still keep showing the same ads to you. So those are actually the kind of one challenge from the system building side, that really to make personalization super useful, there's still a lot of challenges that we haven't solved yet. On the other hand, another probably most talked about challenge is about the trustness. Like how do we actually make user to trust that their private information is well protected? So in exchange that the things actually can be quite useful, but we shouldn't, as a user, as a consumer, we shouldn't be worried that our personal information will be leaked. So those two challenges are probably the most talked about challenges I can think of.
Yeah, so I think for me, when I'm using, for instance, these large language models, GPT or Claude, Llama, I think when the reason why I sometimes feel they are not enough, or when they are not accurate enough, I think could be because the model doesn't know me well. So for instance, I think in the cases like when I'm asking the GPT to write an email for me, then GPT writes some email, but then it's not really fitting my style or how I write things. And I think that's exactly the case where if the model knows me well, I think it means then you can actually ask the model to do a lot of things without worrying about the results. And it's actually really, I think, not just about personalization in terms of like recommendations or other things, but it's really knowing you and basically making everything work really well out of the box without telling the model the details. And I think that's like the exciting part on the application, because we can use these things without telling too much details every time. I think it's also exciting from the technology perspective because giving large context to model means the model needs to handle long context, and that's basically about handling, like making transformer, for instance, long range, all these like different techniques people are really using to make it longer input. So I think on the technology side, it's also quite exciting part to make models personalized.
Great, yeah. Thanks for those responses. I think in summary, I think everyone kind of agrees that there's this kind of balance that we want when building personalized systems that both maximize the user's productivity or how comfortable the user is with the system, while also being like trustworthy and not kind of like creeped out by how personalized the system is to that user. So speaking on the topic of privacy, so there is kind of inherently this tension between the level of personalization that a user may want when interacting with an AI system versus what the person who's deploying the AI system might want to deliver to the user. So one non-AI example of this is online targeted ads. Like they're the company that's making these ads or like making the ad recommendation system wants to give as personalized recommendations as possible that will get the users to buy as many things as they can. But at the same time, as the user, if I see an ad for something that I was talking with my friend about like 10 minutes ago, that creeps me out, and like that makes me want to engage with the technology less. So what role do we as researchers and developers of these systems have in kind of balancing these considerations of what the user wants versus what the system deployer wants to deliver?
Well, I would think the developers have the key role in this because they're actually figuring out, well, what's the system going to do? Maybe a question related to that is what kinds of frameworks, conceptual frameworks, can developers use or companies use to, once again, use that phrase, prevent people from being creeped out. I actually do use that phrase creepy or that word creepy in my privacy classes because it's useful. It's this vague feeling that something's gone wrong and a person feels a little bit violated. So we need to figure out how to prevent that because when people feel creeped out by technology, they use it less, just naturally. And that's a drawback for the provider of some service or some system. Anyway, getting back to my interpretation of the question, there are a few different sort of conceptualizations of what privacy is. And one that's really useful here is something called contextual integrity, which is the idea that folks have expectations for certain contexts that information is used in when they provide it. So same piece of information I feel fine sharing with, sometimes piece of information I feel fine sharing with a friend, but when I see it used to target ads towards me, all of a sudden something's wrong. So there's these different spheres that we maintain. Very personal ones, slightly less personal ones, maybe with friends or acquaintances, and then some professional ones, workplace stuff, and then stuff that we do as consumers. So getting to the example of behavioral advertising you brought up briefly, where a piece of information is taken in a way to the user that appears out of context. That's something to avoid, and the way we look at this with contextual integrity is it's been violated. Some assumption has been broken about how my personal information is going to be used. Maybe, for example, the fact that I was searching the web for help with some medical problem, and all of a sudden Amazon pitches towards me a bunch of products related to that. I was just searching the web. Those linkages might be there behind the scenes, and an all might be legal, yet at the same time, person feels uncomfortable. So having that idea of user expectations, I think, is key to helping people feel comfortable about personalization in general.
Scott, could you give us some insight from like the industry side? What considerations people at Meta take about like this kind of privacy stuff, like when you're developing Llama? Like obviously you don't want these open source models to be able to like leak users' private information from the training data. So could you give some insight on like what kind of considerations on the industry side that from like the people who are actually developing these models that you take for privacy preserving?
Yeah, so, well, first of all, I'm not actually part of the Llama team. So I probably not the best one to comment on that, but from what I know, every release we actually have a lot of like legal proven that type of things actually to check that. For example, one thing I do know that, like for example, every model release, we also release the paper. So the paper actually describe very clearly like what kind of data actually is used in the paper, is in training the model. And then also from my experience, like I'm actually in the more academic fundamental research side of the organization. And then our compute infrastructure actually cannot have any company data or the user data. And also for the company's user data, even if you are an employee, you cannot really access because even, for example, if I want to access some data, then system will actually immediately ask me to submit some requests and then the proper vetting process and then authorization process. So I think especially like these kind of things is under a lot of scrutiny. So we are probably not just Meta, but in general, companies are actually very aware of that and then try to be careful on those kind of things.
Awesome. Cool, yeah, thanks for the response. What role do you see kind of regulation playing in this privacy issue? Like some people are concerned about regulation maybe like slowing down the progress of AI too much or like placing too many barriers. Regulation, like it's especially kind of tackling this issue of like making sure that users' data isn't unfairly used. So do you see like regulation actually maybe potentially proving to be like a hindrance in building personalized AI solutions? Or do you think this is maybe not as much of a concern? Anyone who wants to answer it? Anyone who has thoughts?
Okay, sure. Difficult to answer. I don't think I'd load my answer in one way or the other. Legislation is something that helps protect folks a lot of the time, but at the same time, there has to be an acknowledgement that we can't see the future, and lawmakers, in spite of whatever power they have, they can't see the future. There are also a population of leaders who sometimes struggle to stay informed about detailed technical issues. I think that's natural because they have a lot of other responsibilities. So because of that, there becomes this ecosystem of policy aides and policy advisors and think tanks, all of that. And then sort of off to the side, but also very important, are industry self-regulatory bodies that sometimes provide guidelines on how privacy should work. So it's difficult to figure out this balance ahead of time. We do want legislation that helps protect people, but we also don't want legislation that limits progress. And it's difficult to say one way or the other which laws have done this and which haven't. I think folks have generally seen GDPR as a great thing. There's this aspect to it that's of benefit to certain companies more than others, actually. So larger organizations find it easier to hire lawyers and pay them to be on staff full-time to make sure they are in compliance of all the laws of each of the countries around the world that they're subject to. That's difficult for small organizations. They might just find a privacy policy generator and use it and just try to play along with it, but they don't know if they do. So I guess ultimately my answer just has to be really pragmatic. There's elements of concern on all sides, and there are just lots of stakeholders.
Awesome. Do you guys want to add any thoughts? Or?
One small add, I think, is, so I think, as you said, regulations, I think people could be very concerned about regulations. I mean, they could be like freaked out when they recommend things that I just talked about with a friend a few minutes ago. But I think for some people, to be honest, like me, it's quite helpful. I mean, it's not just about company trying to sell the product, but then also it saves my time if I was actually looking for that product. So perhaps that's also different for different people. I think that bar, I think it's also what Shomer, what the Shomer just said. I mean, that in the previous, what he said previously, which is, I think, the level of, I think, the privacy people are comfortable with is different. That's also something maybe to be personalized too, because maybe I'm not super sensitive to those things, I think, as much as others are.
Right. I think that also ties back to what Shomer said about explicitly getting users' consent about opting into the level of personalization that they want. So moving on from like these kind of more philosophical and ethical questions, let's talk about like some of the technical challenges of personalization. So Minjun, what role do you see academia playing in like building personalized AI systems, and what strengths do you think academia brings to the table that industry may not have?
Yeah, so of course, I couldn't probably say industry doesn't have, it's probably more accurate to say academia can do it, first of all. And number two is the resources needed to do that is not as much, that industry doesn't have a clear advantage over academia. So I think from my perspective, the concept of personalization in generative AI, especially language models, is usually done by giving different prompts to the language model. So I'll give an example. If I want the language model to be acting certain way, then how I want the language model to act will be governed by the prompt text that you put to the language models. Like, okay, you are a helpful assistant, respond this kind of questions, but do not respond this kind of question, and so on. So this is basically what people call prompt engineering, because you only change the input to the language model. Now, if you think about this method, of course, it's very powerful. It's good that you can just change the prompt to personalized language model. But then now you're consuming a lot of input. If your model can only take, say, 10,000 words, and if you're using, say, 7,000 words for the personalization, then you only have 3,000 words left to use for your own application. And it just can get much longer when you are actually trying to personalize more and more. So that's why I talk about the fact that the personalization is not different from making model long context. So that's also, I think, why a lot of companies are trying to build like 100 million token language models, like Google is working a lot on, I think. And so regarding that, what I want to really emphasize is the fact that then why can't we fine-tune language models for personalization, right? Because if you want the ultimate personalization, then some might want to consider, okay, let's fine-tune language models with your personal data or what you want the model to be. The issue with that is it doesn't work well as much as giving the prompt. So that's because when you're training the model on, of course, not too short, but then not really large amount of data, and when you're fine-tuning a model, whenever you fine-tune a model, you have to risk the forgetting issue or the performance degrade issue. And model simply doesn't work as good as it used to be. So that's why, and also, of course, there are other issues too, like language models. If you change the weights, then it becomes much more difficult engineering problem on the server side. So what I'm trying to say is that right now, all the personalizations are being done by changing the prompts and not actually changing the model's weights a lot. And that's, there is an inherent limitation to that. And I think this kind of a problem is requires us to understand how models work more deeply. Scientific aspect of how basically these parameters really change when you're training models. And I think that kind of thing is something that academia has quite good strength on, because we usually try to understand the models first, and we're trying to develop some theories for how models train. And Of course, I'm pretty sure industries can do same things too, but at least we're on the same ground on that aspect.
Right, yeah, that's a good point that prompt tuning has like, prompt tuning has strengths that, like fine tuning does not, but also the kind of framing of user preferences or like what kind of personalization they want it's like a very explicit way of framing it where like the user already knows what kind of assistant they want. So you kind of just like put it in text into the prompt. Do you think fine tuning may have more strengths in like this kind of behavioral preference learning, like online learning of user preferences and personalization, and something that like maybe prompt tuning cannot like explicitly capture?
So I think, first of all, as you said, I think the biggest advantage, of course, is the fact that we don't have to put the prompts, so we're not consuming input tokens, so it's more efficient and you can use longer context. So I think it is possible that also this kind of method can induce more complex interactions. But then I think that's still we're still far from it. I don't think it's not even yet close. I think we're still worried more about can we fine tune stably so that it actually works as good as putting the text as the prompt. And I think for instance, one of our recent research was trying to achieve that, which we failed, didn't work well. And our conclusion was that we're still actually not, we don't have a good methods to make this work. And in other words, what that means is I think how models learn, which is through the gradient descent, is quite different from how I think humans learn, which is probably not gradient descent. And I think we have a better way of, in some sense, tuning the model or tuning our brain as we see new information every time. We're much more robust, but then the models that we train with the gradient descent, they're usually shifting too much when we're fine-tuning that. If the data is not big enough, and also if you're trying to shift a lot, then I think it's causing a lot of issues. So I think probably we're at that point, but maybe there's a bigger, of course, advantage. I mean, like for instance, if you can fine-tune on large personal data, then what we can reach is even personalizing on maybe my entire personal context, not just like a few hundred tokens, but maybe my entire life or my entire social media, etc. And that will be really powerful because that's like knowing me really well, but I think that's a really difficult thing. And people have to use RAG or this basically some sort of, I think, prompt-based methods to do that these days. And that's not really inherently personalizing to me.
Right. Great point there. Scott, what strengths do you think that industry has? I mean, among the many strengths that industry has, what strengths specifically for this challenge of building personalized AI systems do you think that industry has that academia cannot fully tackle because of like limited scope or like not being able to like not having as much ease of access to users perhaps because you have to go through IRB, and I'm not sure if Facebook does.
I actually don't know about IRB thing, but as I was listening to what Minjong was saying, I think fundamentally from a technician or research scientist or engineer's point of view, there are just actually tons of interesting challenges actually to do personalization well. So this is actually even, I think, earlier than the large language model era. Like for example, imagine that you're doing personalization for like millions of users or even billions of users. And then in that case, on the server side, it's still very hard to do that. And then usually you can only have very little space to form some kind of representation of each user's preference. And then those kind of things were obviously kind of like very crude, and then cannot really have the very fine-grained information. And then also, how do you actually kind of use that to combine with the big system to actually perform well? And then those kind of challenges are actually kind of similar to a lot of problems that Minjo just mentioned. For example, one of the difficulties that we probably know is that usually large language models, so they're large. So it's very hard to actually imagine that every one of us has a phone, and then the phone actually serves that kind of model, and then you can just do whatever on that model, and then your data, personal data is within your device. That simply is not feasible. And then, so talking about other representation, the Prom is actually a nice representation, but it has many issues that Minjo just mentioned, and also it's very, very kind of brittle, so it's actually not very good in terms of making sure the behavior is right. And then other method could be like, maybe one possibility is that your big model is still on the cloud, but your personalization things is actually on your local device. In that case, maybe some kind of parameter efficient way to do fine tuning. It's a way to actually use a much smaller parameters as your personal representation, those kind of things. So to me, there are just actually tons of interesting research problem and the engineering challenge that's super exciting.
Yep, definitely a lot of open research problems there. Another problem with personalizing AI systems is that you're inherently working in this like very low data, low supervision regime. This is something that low supervision is like something that people in the ML community generally, NLP community as well, have been trying to solve for like many years in like different domains such as low resource translation, for example. What do you think, what insights can we kind of incorporate from that into this challenge of personalizing using like a small amount of user preference data? Yeah, and anyone.
Maybe
anyone who has thoughts.
Yeah, one idea is probably like, because each individual probably you still have very little data, but maybe you can do some kind of clustering so that you can aggregate similar users' data and then try to use that as the basic profile, and then each individual's difference probably just actually kind of small delta on top of that. Yeah, and so usually in the, for example, the low resource domain, people try to do is that if there's something more general that we can borrow from, like we train a model using rich language, then some of the aspects probably can be transferred to a different domain. And in that case, probably we can use similar ideas to tackle this challenge.
Yeah, okay. So I think Scott gave really practical suggestions. I think my suggestions are probably far from practical, but I think one thing that we might need is connecting my previous statement, which is, can we have something else than gradient descent for learning? So I think learning algorithm, I think there is probably good part about gradient descent, but then I think some fundamental limitations, and I sometimes feel that the fundamental limitation is when you're trying to inject a small amount of knowledge, because I think recent research has been showing that it's actually very difficult. Some of our research also has shown that too. So I think maybe we need something else than that. And that's like really fundamental machine learning problem. It's not just about language, I think.
I'll answer just briefly. I'll give a very different sort of answer, which is understanding the problem domain and not just treating it like generic machine learning problem. And that's what I think a lot of folks end up doing, maybe in part because of machine learning courses that they take, where they're just given a problem and told, well, machine learning, supervised learning, bam, done. You do have to look at your data, and you do have to understand the people who are represented by it. And by doing that, you can all of a sudden make insights that you couldn't just by treating this as generic low resource problem. So understanding people, understanding the domain, the structure of the data, and having just an overall operational concept, I think is useful for a lot of problems here.
Yeah, no, thanks for bringing that up a lot. I definitely strongly believe that we should, look at what users actually want, look at the data, and build solutions accordingly rather than the other way around. It's also nice to hear Scott mention clustering. It's good to know that there's still a place for old school methods even in this era of LLMs. So we have like about 5 minutes left. So I'll end the discussion on like a more optimistic question, perhaps. So one issue with large language models and any other data set that's, or any other model that's been trained on large amount of like human scale data is that they end up representing the mode human. So they don't really necessarily represent people who are from like marginalized communities. So what role do you think personalization can play in building more fair and equitable AI systems? And do you think it's maybe a double-edged sword that we may end up actually perpetuating these marginalization issues even more, maybe if we don't do it correctly? So kind of a two-parter. Anyone can answer?
So I think the easy answer there is, well, personalization could be a great boon to addressing diverse populations. The big question is how to do it well, how to do it respectfully for different groups. And I think there's some balance between addressing individual groups explicitly somehow in the structure of your problem and recognizing that that approach has limitations. The types of people, for a lot of ways in which we categorize people, we'd like to think of them as closed sets, but it turns out they're pretty open-ended. And gender is a good example of that. So yeah, we can get past the traditional male-female and add an other, but do we really need to do that? Can we just think of gender as an open-ended set? Can we look back at the problem we're trying to solve and figure out, well, is there something else we should be looking at instead? So that's a challenge. And I think personalization, this general term we've been talking about, it can mean a lot of great things. But it just, again, reduces down to respecting people's identities and what they want.
Yeah, any thoughts you guys want to add to that? Or to kind of just wrap up the discussion generally?
Yeah, I mean, I'm just thinking, because I think you raised a very good point that, you know, the model could be just the mode. And then so in that case, I feel that personalization is actually the nice way to kind of balance that back. And then fundamentally, it's really about data. So if if the model training process does actually have some kind of access, or the inference time does have that kind of access to user data, then hopefully those kind of things can, adapt the model to more like fit your purpose. I mean, fit your use case scenario better. Yeah. And then in general, I was also thinking this is probably not so related to personalization. I was doing retrieval augmentation. One of the angle we argue is that retrieval kind of help you to deal with the long tail type of information, because in that case, you kind of change the distribution and get that. And then kind of feel that if you do have that kind of information about each individual, and then that's kind of the long tail thing as well.
Yeah, also I wanted to add a bit more on what you said, which is language model is a kind of mode of the entire human civilization, right? So I think it's a really good point because, as you said, I think it's a mode if we do not give enough context to it, which means, for instance, if you're training a language model on some novel like Harry Potter, and if you just train the model to predict the next token without giving the context that this is a novel, then you're basically making the model generating wrong facts, right? I mean, if you ask the model, okay, is there like chimera, and then model will say yes because it's trained on Harry Potter. Then there are two now choices. One is that you either do not train on such novel. Number two is you train on it, but you give enough context. And I think context is basically also the most important thing about personalization. So I think maybe really important thing about making this model really personalized is maybe we're giving enough context to every data we're using. Because when you give enough context to data, then which means basically you're giving the personalization context, or basically that context that's specific to that data, then at that point, then we're actually enabling the model to be able to really be not the mode, but then to be more exact, I would say you can actually instruct the model to be any kind of personalization we want it to be. So I think I just wanted to touch on the more the technical part too. Yeah.
Cool. Yeah. Thanks for all those responses. I think that brings us to kind of the conclusion of the panel. In summary, I think from the discussion here, everyone kind of sees like there's a lot of opportunities for personalization, a lot of potential benefits to users, but also it's very risky. And to do this in a safe way, we must really understand and engage with users, understand their needs, understand their domains, and then build methods accordingly. So yeah, thanks everyone for the very enlightening conversation.
Thanks for moderating.
Thank you.
Yeah, thank you. All right, thanks everyone.
Anyone would like to share their personal experience using AI? There you go.
So just want to share with my personal experience. I'm a data scientist, and I'm using a large language model quite a lot, and in my research, in the works, and all of that. And the last panel was we were speaking about personalized AI and ways how we can maximize of personalization. So I do use usually Llama locally on my machine because I do not trust OpenAI, Meta, and all of those closed source companies that collects our data for their own good, and we pay them to use our own data and our own things that we need to, right? I don't think this is quite fair situation for end user. For the companies, yes, it is obviously, but anyway, about the personalization. The way I do my personalized work with large language models, I use RAG quite often, so, and a mixture of agents. So essentially, in our architecture that I use, I put the prompt and the things that I need to do, and that generates the question. And after that, using RAG, it goes through my personalized file, and based off that personalized file gives me personalized reply based off the RAG system. That's how I use it, essentially. And given the limits of the context window, right, if we're having two different models, so essentially for the querying part and for the personalization and RAG part, we can essentially extend the context window for the query that we're using. Yeah, that's it.
Hi, I'm the student majoring in AI engineering, and actually last year for my research and development project at my university, I had to develop the personalized AI recommendation system. So regarding that, I have two questions. So the first one is that, like on the stage when I presented my final prototype or demo, like a lot of the people asked me about the etiquette challenges, like etiquette issues. So I believe that not every AI has like absolute 100% free from etiquette challenges, and at least one or something. So my question is that, is it possible to like for every AI app to have like no etiquette challenges, or even if we have like at least one etiquette challenges, how can we try our best like to minimize least challenges for the for the AI application that we develop? So do you get what I mean?
Yeah, absolutely. And thank you for the questions. And I hope some of us who know some of the answers will run to it during the demonstration session and maybe topic about the answers. All right, thank you. Anybody else? Can I get one little volunteer? Yeah, there you go. Running great, Luke.
Hi. I'm a startup co-founder, and I once had to help a friend create a pitch deck. And I was kind of familiar with his particular product, and quite a bit familiar with like making a lot of pitch decks too. So it took me a total of like maybe 3 hours. So creating an outline, looking through my little file of like, smart quips and quotations, checking out like the hot list of like pitch decks that got like funding and all that, and down to the final copy, maybe like 3 or 4 pages. And then one of my friends said, hey, you know what? I'll just go ahead and use the newly released ChatGPT. He said it took him just 10 minutes, prompted 4 times. And I said, okay, I'm not going to look at it. Let's go take it and give it to that founder and let him judge it from, give a number from like, let's say 0 to 100. I got 88, that got 91. I'm like, I'm not wasting time doing this anymore, man. It was that good.
Yeah, thank you for sharing your experience. It feels like, to me, some of the tasks, when you use AI, it feels like you can make just one homemade brownie, or you can get the box version and bake it, right? And like most people would not be able to tear it apart. So for most of the tasks, it's like that. And what we have seen as a VC as well is that for really specialized tasks, the professionals are still beating out AI. I'm not sure how long that's gonna balance, right? For those of you startup founders over here, or not even founders yet thinking of startup, we do have a full team of VC from SCBX over here. So if you want to pitch your product, or even just want to bounce ideas, like, hey, I'm thinking of making this. What do you think of it? So team of VC up here being to you. All right, with that being said, we do have more swags to give out. You can go over to the front counter, scan QR, and answer the survey about this event. What did we do well? What did you like? What did you not like? Did you like the MC? Did you talk too much? And the first group of people who answer the survey will get the swags by supply levels. All right, at the end of this event, on behalf of the co-hosts, Sahara AI, SCBX, and Sambanova, I would like to thank all of you for joining us, and I would like to thank all the speakers, moderators, and especially our partners. So we have AWS, Google, Cohere for AI, UBC, the Vector Institute, AI Tools, Put Together AI, EPFL, Penn State University, Meta, KAIST, and Stanford University. Thank you all for their support very much, and we look forward to bring this kind of event back in the future. Right, so if you do like this event, please go follow SCB10X, Sahara AI, and Sambanova on social media. We are on Twitter, we are on Facebook, we are on LinkedIn. Look up my name, look up our CEO name, connect to our summit. All right, that being said, thank you very much, and see you at the networking event.